He stands at a quiet shore of numbers and light, a witness inside a small planet, and looks outward with instruments that sharpen the night. The sky above him is not a dome. It is a story whispered over billions of years. Each photon, a word that left its speaker long ago. He waits for them to arrive, the faint survivors of a journey through expanding space. He learns by listening, because the universe writes slowly. There is a place his listening cannot pass, not because there is a wall, but because time itself withholds permission. The edge he seeks is a horizon built of speed and history, a boundary written in the language of light. Nothing outruns light in a local sense, yet the stage on which light travels can stretch between heartbeats. Expansion lifts one island of galaxies from another, and the gulf widens while the message still sails. The result feels like a trick, yet it is a patient arithmetic. The ancient signals that reach him today were launched when distances were smaller, when matter was young and fire still had a memory of birth. He learns that the observable universe is not the universe. It is only the region that has managed to speak to him so far. Beyond it, there may be more of the same, or there may be strangeness. He cannot point to a rim as a sailor might, because the horizon here is not painted on a surface. It is a curve inside a map of time, the farthest place from which light has had enough time to arrive since the first second sharpened into minutes and ages. He studies the fog that once filled everything. In the beginning, free electrons, protons, and photons formed a bright and crowded broth. Light could not travel far without being scattered, so the universe kept its secrets. Then it cooled, the fog cleared, and hydrogen congealed out of brilliance. At that instant, space became transparent. Photons left home and began their long migrations, stretching with every heartbeat of expansion. They still arrive, cooled to microwaves, a thin winter over the sky. He calls this quiet glare the afterglow of creation. He imagines a line drawn from his eye outward, a straight path that is not straight at all when counted in cosmic time. Along that path, galaxies emerge, not as they are now, but as they were when light escaped them. The farther he looks, the younger they appear, until the galaxies have not yet assembled, and only clouds of nascent matter drift in dark gravity. Farther still, the path reaches the veil of first transparency, and light there has been stretched so thin that it hums rather than shines. The edge is not a wall. It is a last photograph of a childhood that continues to recede. He remembers the rule that makes this horizon unavoidable. Light has a finite speed, and the age of the cosmos is finite too, even if its size is not. A finite age with a finite signal speed draws a circle around every observer. This is not arrogance, it is geometry. Every point in space owns a horizon centered on itself, like a campsite lantern whose reach is set by time. If he were elsewhere, the circle would follow him, and the edge would move with his new home. There is no universal center, only local circles of possibility. He learns to speak of co-moving distance, the measure that accounts for expansion while pretending the fabric stays still. In this language, the farthest visible matter today is not the naive distance of a simple line. It is a larger reach, because space inflated while the signals travelled. He hears the number and feels a shiver. The number is not a myth. It is the honest yield of equations that have survived every test thrown at them. The edge, in this reckoning, sits far beyond the naive imagination of a young species. He notices the quiet cruelty inside the concept. There exist galaxies that will never know him, though they are as real as his own. Their light is forever trapped behind the arithmetic of expansion. Other galaxies sent their light early, and the message arrived only because of a timing accident, a favourable start before the distance grew too severe. He senses a tenderness in that realization. Every photon that reaches him is a survivor and a messenger from a past that no one can revisit, a testimony to the brief luck of transparency. He listens for the other boundary that hides inside the first. The visible past is one thing, the reachable future another. Even if a beacon is lit tonight, there are realms that will never receive it, no matter how long time endures. The universe is expanding, and that expansion is not merely coasting. It is driven by something that looks like pressure with negative sign, a quiet acceleration. He does not name it with confidence, he only observes its effects. The result is a horizon of destiny as well as memory, a limit on meetings not yet attempted. He turns from equations to images, but the images remain faithful to the same truth. The faint mottling of the microwave sky is not mere decoration. It is evidence that the horizon is a fossil boundary. The fluctuations are fingerprints of sound waves frozen by transparency, a map of how matter and light once conversed. The map is complete in its way, yet it hints at larger rooms outside the corridor. Patterns repeat with a statistical rhythm, but the repetition does not compel a finite space. It merely states what has been heard. He lets a simple metaphor settle. A ship at sea sees a horizon, and walking to the rim never reaches the rim. The sea is without edge, yet the sailor is bounded by sight. The cosmos is like that. Only the water is time, and the curve is the history of light. The horizon is not a fence, it is a promise. It promises that seeing is always a negotiation between speed and age, that curiosity must work with absences as well as arrivals. It promises that mystery survives, not because nature is coy, but because the conditions of knowing are part of the story. He accepts that this edge is not a failure of tools, it is the architecture of reality as understood today. To stand at the silent horizon is to discover that limits can be beautiful. A limit can focus attention, invite craft, and refine patience. The listener becomes a curator of whispers and a student of what cannot be forced. The boundary teaches him to ask better questions. What can be inferred when direct sight is impossible? What shadows reveal about the shape of their makers? What the oldest light implies about distances he will never touch? He breathes with the understanding that meaning survives even in the presence of a horizon. There is dignity in a darkness that is not nothing, only distance. There is humility in knowing that the observable is a gift from a larger stage. The sky is both mirror and window. It shows the inside of his own finitude, and it frames a world that continues regardless. The edge is a teacher. It instructs without scolding. It beckons without yielding. It asks for attention, and it rewards attention with the quiet thrill of a truth that feels inevitable. He learns the names of the first cartographers of darkness, and the dates when the map began to take shape. In a 17th century observatory, Oloroma watches the eclipses of Jupiter's moon Io drift late and early with the seasons. The delays refuse to fit a perfect clock. He realizes they are not errors in the moon, but the travel time of light itself. The sky does not answer instantly. Time and distance are tied by a finite speed, and with that recognition, a limit is born. A century later, James Bradley notices a subtle lean in starlight called aberration and confirms the same truth from another angle. Light is swift, but not infinite. The cosmos will always be a conversation with a delay. 2 centuries pass, and the dark of night asks a louder question. Why is the sky not filled with endless light if stars stretch forever? The puzzle is debated in salons and lecture halls, and it becomes a pressure on theory rather than a curiosity. The answer, when it arrives, does not mock the question. It points to finitude, to an origin in time, to the possibility that the universe has an age, and that starlight has not had forever to accumulate. The darkness of night becomes a clue, not a failure. In the early 20th century, gravity is rewritten. Albert Einstein offers a geometry where mass and energy tell space-time how to curve. The equations admit many possible worlds. Alexander Friedmann in Petrograd solves them for a universe that can expand. Georges Lemaitre in Belgium links that expansion to astronomical data and imagines a past denser and hotter than any star. Theory is ahead of sight, but only by a small margin. On a mountain above Los Angeles in 1929, Edwin Hubble uses the Hooker telescope at Mount Wilson to measure distances to galaxies by the heartbeat of Cepheid stars. He pairs those distances with redshifts drawn from careful spectra, many of them first captured by Vesto Slipher at Lowell Observatory. The relation is unmistakable. The more distant a galaxy, the faster it recedes. The stage itself is growing, carrying the actors apart. A new way of seeing follows. To look far is to look back. The night becomes an archive where older scenes sit behind the newer ones, and the telescope becomes a time machine bound by light's speed. The words observable universe gain precision. No wall marks it, yet data now sketch its boundary. Every observation is stamped with a travel time. The radius of the archive grows with the age of the cosmos. The map is temporal as much as spatial. The early 1960 seconds add a dramatic chapter. A radio source named 3C 273 inches. The constellation Virgo shows a bewildering redshift when Martin Schmidt deciphers its spectral lines at Palomar. Quasars are born as a category, and they push sight deeper into the young universe. If such objects shine from times when galaxies were still assembling, then the path outward truly crosses eras, not just distances. The edge starts to feel like the boundary of a childhood photograph waiting to be found. The photograph arrives from an unexpected instrument in New Jersey. In 1965, Arno Penzias and Robert Wilson labor over a horn antenna at the Bell Labs site in Holmdel, hoping to perfect a radio link. A stubborn hiss intrudes no matter where they point, no matter how much they clean. Even the removal of roosting pigeons does not help. A few kilometers away, a Princeton group led by Robert Dick and advised by Jim Peebles is preparing to search for a thermal afterglow of a hot beginning. A phone call stitches their stories together. The hiss is not an error. It is the sky itself, cooled to a few degrees above absolute zero, arriving from every direction with the same quiet power. The cosmic microwave background transforms a philosophical horizon into a measured surface. The universe has a memory written in radiation. Satellites climb into orbit to refine that memory. In November 1989, the Cosmic Background Explorer begins to circle the Earth in a polar path. Its instruments carry two promises. One will test whether the background truly has the black-body spectrum of an ideal thermal bath. The other will look for tiny variations that might be the seeds of structure. The results are decisive. The spectrum is perfect within the limits of measurement, a signature of a universe once in thermal equilibrium. The fluctuations are faint but real, ripples at the level of tens of microkelvin that map the infant cosmos. Names like John Martha and George Smoot become tied to those confirmations, but beyond the medals lies a deeper consequence. The surface of last scattering acquires texture that can be read, and with it the horizon is not just distance, it is pattern. Two more missions tighten the focus. In 2001, a probe parks itself at a gravitational balance point far from the warmth of Earth and stares for years. The map it produces shows a sky speckled with anisotropies whose sizes and amplitudes encode the geometry of the universe and the matter within it. A few years later, a European satellite adds even finer detail, measuring polarization as well as temperature. The statistics extracted from these maps tell a consistent story. Space is nearly flat over vast scales. The recipe of the cosmos includes dark matter and an even stranger component that pushes expansion to accelerate. The horizon is no longer just the edge of what has had time to reach us. It is also the stage for a future in which much will slip forever beyond contact. That acceleration was not discovered in the microwave sky alone. In the late 1990 seconds, two teams scour the heavens for dying stars that flare with a standard brightness. They find that distant explosions appear dimmer than expected in a simple, coasting universe. The inference is bold but unavoidable. Expansion is speeding up. The constant of acceleration, or something akin to it, is reshaping destiny. With that result, the meaning of beyond shifts again. There are regions that could have been met if expansion had slowed. With acceleration, they recede into permanent elsewheres, even if time runs long. The word horizon acquires qualifiers inside laboratories and lecture halls. Particle horizon marks the farthest light that could have arrived since the first transparency. Event horizon marks the boundary beyond which signals launched today will never be received. The distinction arises not from poetry but from measurements and the models they support. The two horizons bracket memory and possibility, and both are drawn by the same set of discoveries that began with the delay of I/O and now include the color of ancient microwaves and the faintness of far supernovae. New eyes continue to be built to chase closer to the limit. Giant mirrors climb desert summits and volcanic ridges. Interferometers link dishes across continents to sharpen vision. Spectrographs that can pass starlight to a hair's breadth measure redshifts with exquisite care. These tools do not push past the horizon. They engrave it more sharply on the mind. They show the young galaxies as smudges of blue light, stretched and reddened as they fall toward invisibility. They capture the cosmic web, a network of filaments and voids that was already planned in the tiny ripples of the microwave map. Each instrument adds a layer to the same revelation. The edge is empirical. It is not guessed. It is drawn by the sky. Every milestone carries a location that can be visited on a map of Earth. A hillside in Copenhagen where a moon ran late. A mountain in California where galaxies receded on glass plates. A horn antenna in New Jersey where a hiss refused to be tamed. A launch pad on the Pacific coast where a satellite rose into polar dawn. An observing field in Chile or Hawaii where supernovae blinked and told of an accelerating stage. The trail is terrestrial and practical, yet it aims at a boundary far beyond the reach of any vehicle. The discovery of the edge is a human story of rooms and rooftops, of patient calibration, of error budgets and stubborn signals. It is also an origin story for a new humility. The cosmos can be measured and still remain larger than measurement. He considers what makes this list of names and dates more than a chronicle. Each step replaced imagination with evidence. Finite light speed turned speculation about limits into a clock. Expansion turned distance into history. Microwave afterglow turned origin into temperature. Supernovae turned fate into a function of a constant that resists explanation. The horizon emerged not as a curtain lowered by myth, but as a boundary written by the interplay of time, speed, and the shape of space-time. The edge is discovered, not invented, because the sky refused to say nothing when asked carefully. He watches a rule take shape in the quiet of mathematics. The rule is simple to say and hard to live with. Light is swift yet finite, and space is not a stage that sits still. Gravity is geometry, curvature is motion, and distances can grow without anything rushing through them. With these ideas gathered into a single picture, a limit is born that is both precise and elusive. It does not guard a border like a fence. It draws a horizon that changes with time, a shoreline that recedes as it is approached. Relativity gives the grammar. In the general form, clocks and rulers are not universal. They are local instruments carried along world lines that curve under the influence of energy and momentum. The field equations link curvature to content, turning mass, radiation, and pressure into sculptors of spacetime. For a universe that looks similar in every direction at large scales, the geometry simplifies to a metric that stretches or contracts with a single function of time, the scale factor. In these coordinates, co-moving locations keep the same labels while the distances between them breathe with the scale factor. Light follows paths where the space-time interval vanishes, so its travel is coded by an integral that weighs time against the changing scale of space. The act of seeing becomes a story of how the scale factor grows. A horizon emerges from that story because the integral is finite. Only a limited range of co-moving territory can send signals that arrive by the present moment. This boundary is called the particle horizon. It is not a material shell. It is a value in the ledger of expansion, the total co-moving distance light could have crossed since the first moments when space became transparent. Proper distance to that boundary today is larger than a naive multiplication by age and speed, because the fabric stretched while the signals were in flight. That growth is the first hint that the edge is not a fixed rim. It moves because time moves, and because the scale factor does not idle. A second horizon speaks to possibility rather than memory. If one imagines a beacon switched on tonight, there is a maximal co-moving distance from which a reply could ever return, even if time stretches without bound. This limit is the event horizon. Its existence depends on how the scale factor behaves in the far future. If expansion decelerates and asymptotically slows, distant voices can eventually be heard given patience. If expansion accelerates in a sustained way, as observations suggest, then the integral that defines the event horizon converges, locking in a finite domain of ever and excluding a larger domain of never. The universe then has two edges written in the same alphabet. One encircles what has spoken already, the other encircles what can ever be reached. The idea that galaxies can recede faster than light without breaking the speed limit of special relativity follows cleanly from this picture. Special relativity governs motion through space, setting c as the cap on local velocities. The cosmological recession is not motion through space, but an increase of the space in between. Two co-moving markers can separate at an effective rate larger than c, because no marker locally outruns a light beam in its own neighborhood. Light still wins every local race. The expansion simply lengthens the track under their feet. This distinction is not a word trick, it is carried by the geometry of the metric itself. It explains why redshifts can be extreme without any individual object feeling a superluminal wind. The Hubble radius is another measure that tempts misinterpretation. Defined as c divided by the instantaneous Hubble parameter, it has the flavor of a horizon, and in some epochs it roughly tracks the boundary between regions moving away slower or faster than light. Yet it is not the same as the particle or event horizon. It can grow or shrink depending on the cosmic recipe. During periods when the expansion decelerates, the Hubble radius grows, and light from previously superluminally receding regions can drift inside and become visible. During periods of acceleration, the Hubble radius tends toward a finite value, and more territory slips outside. The moving shoreline image becomes literal. The border between visible and invisible is dynamic, governed by the balance of matter, radiation, and the component that drives acceleration. Cosmic time is another subtlety. In a relativistic world, simultaneity is usually a matter of convention, dependent on motion. Yet the near-uniform glow of the microwave background defines a natural cosmic rest frame where the radiation looks the same in all directions. In that frame, one can speak of a universal age measured since the hot beginning. Horizons are defined with respect to that age. This does not reintroduce an absolute clock into physics. It acknowledges that the large-scale uniformity of the sky offers a convenient slicing of space-time for cosmological discussion. Within that slicing, the edges are not artifacts of choice, but consequences of the finite speed of signals and the growth of the scale factor. The birth of the limit is inseparable from the early behavior of the scale factor. In the young universe, radiation dominated the energy budget, and expansion was rapid but decelerating. Later, matter took over, and the deceleration continued, though more gently. In the recent past, on cosmic terms, the component that resembles a constant energy density began to dominate, and expansion entered an accelerating phase. This sequence affects horizons in concrete ways. The particle horizon expanded as time accrued, pulling more distant regions into view. The event horizon emerged only when acceleration asserted itself. From that moment, there existed a radius in co-moving terms, beyond which signals would never arrive, even if sent immediately and patiently awaited forever. The idea of beyond shifted from a temporary absence to a permanent exclusion. Inflationary behavior, at very early times, adds another layer to the origin of limits. A brief epoch in which the scale factor grew quasi-exponentially would have driven regions that were once in contact far outside each other's view. It would also have flattened any initial curvature and washed away relics of earlier states. The shrinking of the co-moving Hubble radius during such a phase allows a small, causally connected patch to become large enough to encompass the region that later became observable. The present horizon would then be a tiny piece of a much larger domain shaped by that early burst. The limit felt today would thus be an inheritance from both the recent acceleration and the primordial surge. The physical feel of a horizon can be made intuitive by thinking in terms of light cones. Each event in space-time is associated with a cone of possible influences and effects, confined by the speed of light. In an expanding geometry, those cones tilt and shear relative to co-moving grids. The past light cone of an observer intersects a slice of cosmic time along a sphere that marks all points that could have sent signals arriving now. As time advances, the cone widens and intersects larger co-moving spheres, but acceleration prevents it from catching up with everything. Some world lines never cross the cone. They remain forever out of contact. The geometry draws the line without malice. The limit is therefore not a single concept, but a family of boundaries, each born from the same trio of ingredients: the finite speed of light, the evolving scale of space, and the content that drives that evolution. They share a character. None can be pierced by engineering. A faster rocket does not help because the constraint is not technological, it is structural. The best instruments can do is approach the borders asymptotically, gathering older and fainter signals, inferring more from less, and reading the marks left by epochs when causal contact was different. Knowledge can grow within the rules. The rules themselves are steady. There is a final, quiet property that completes the birth of this limit. In a universe where acceleration approaches a constant behavior, horizons are accompanied by thermodynamic whispers. An observer confined by a horizon experiences a temperature associated with that boundary. The implication is that horizons are not only geometric, but informational. They hide, and hiding has a cost that looks like entropy. The details require careful theory, but the hint is enough to change the mood. The edge is not a blank margin. It is an active participant in how information is tallied. He rests the chain of reasoning in his mind. Relativity allows space to grow. Finite light speed allows horizons to exist. The contents of the universe decide how those horizons evolve. One horizon encloses what has had time to speak. Another encloses what may ever respond. A third, more immediate scale, separates regions by recession rate. All shift with the same heartbeat, the scale factor that measures how distances swell. The limit does not arrive as a decree. It emerges as an answer to a set of coupled questions about motion, light, and the recipe of the cosmos. In that emergence lies a form of consolation. The boundary is not arbitrary. It is a faithful reflection of how the world is put together. He turns from principles to the ledger of measurements and finds that the sky has written more details than intuition expected. The faint mottling of the microwave background is not mere decoration, but a code. Its peaks and valleys in the angular power spectrum form a comb of acoustic notes that reveal the density of ordinary matter, the heft of dark matter, and a near-vanishing curvature. The first peak fixes the scale of a sound horizon frozen at the time when electrons found protons and light went free. The relative heights of the next peaks tell of how baryons tugged on those waves and how radiation pressured them back. The entire melody implies a geometry so close to Euclidean that any overall curvature must be subtle across the largest scales we can test. If space bends at all, it does so with a radius of curvature far larger than the domain we can see. The visible world, therefore, looks like a patch cut from a gently flat fabric, and that fact leaves open the possibility that the cloth extends without bound. Polarization adds another voice to the same song. The microwave sky carries E-patterns formed by last scattering and, by the way, gravity lenses that pattern on its way to us. The spectrum of those E-shapes confirms the timing of decoupling and the later epoch when the first stars reionized hydrogen. The lensing imprint maps the distribution of mass integrated along every line of sight. That integrated map matches what galaxy surveys infer by counting and clustering, yet it derives from the oldest light rather than the newest stars. the agreement is not trivial. It says the same gravitational scaffolding that bends the microwave afterglow also organizes the modern web of galaxies. The horizon becomes legible as an ecosystem, not a single snapshot. He follows the thread into three-dimensional maps of galaxies. Redshift surveys draw the cosmic web with millions of points, and within that web appears a faint but persistent ruler. Pairs of galaxies are slightly more common at a separation that matches the scale of those ancient sound waves, now stretched by expansion to hundreds of millions of light-years. This feature, called the baryon acoustic oscillation imprint, serves as a standard ruler that can be read at many epochs. When plotted against redshift, it reveals how the rate of expansion changed with time. The reading confirms an early deceleration that yielded to a recent acceleration. The ruler also reinforces the inference of near flatness. With a ruler and a clock in hand, the geometry leaves fewer places to hide. Supernova measurements refine the same history from a different angle. Type Ia explosions behave like candles with a knowable brightness after careful calibration. Their apparent faintness at large redshift traces the integrated expansion and, when combined with the acoustic ruler, pins down the recent acceleration more tightly. The concordance of these independent probes is not a convenient accident. It is the universe answering the same question through separate channels. The edge of the observable remains tied to light travel time, yet the fate of reachability depends on the way the scale factor behaves. Data that tell the tale of that behavior become a form of X-ray vision for the boundary that separates possible from impossible. He studies shadows cast by clusters on the microwave glow. Hot electrons in cluster gas boost the energy of passing microwave photons through scattering, producing small spectral distortions that do not depend on distance in the usual way. The thermal Sunyaev-Zeldovich effect turns clusters into signposts across immense spans. Counting them and weighing them by their imprint constrains how structure grew. The kinematic version, a subtler change tied to the motion of clusters relative to the cosmic rest frame, offers glimpses of bulk flows across large volumes. The combined picture shows growth that proceeds at a rate consistent with the inferred composition of matter and the gentle pressure that accelerates expansion. The pattern reaches across much of the visible universe, implying that large-scale rules apply uniformly to the edge of sight. Lensing emerges as a quiet giant among methods. Massive structures bend paths of light in ways that create shear patterns across distant galaxy shapes. Statistical analysis of those shears builds convergence maps of mass that do not care whether matter shines. These maps trace filaments and voids in broad strokes, and they show that light and mass are correlated but not identical. On rare lines of sight, lensing magnifies a single distant galaxy into an arc or a multiple image. Such fortuitous telescopes extend vision back in time, revealing star formation episodes near the first billion years. The magnified details suggest that the era of reionization was patchy and complex, that galaxies assembled in clumps and grew through mergers and flows. The horizon is not a blank perimeter. It is edged by a frontier of first structures, whose light is stretched into the infrared and dimmed by time, yet still recoverable. He reads the sky at low frequencies where neutral hydrogen speaks softly. Long wavelengths can map the distribution of hydrogen before and during reionization through the spin-flip line near 21 centimeters in the rest frame. Measurements remain challenging, but early results hint at the timing of the first luminous sources and at the temperatures of the intergalactic medium. As this method matures, it promises a tomographic view of cosmic dawn, a movie rather than a snapshot. If achieved, it will reveal how bubbles of ionized gas grew and overlapped, how the universe transitioned from fog to clarity, and how far the first beacons pushed their reach before expansion stretched their influence thin. He consults the chemistry of the early fireball. The relative abundances of light elements, fixed during the first minutes, are sensitive to the density of ordinary matter and to the number of light particle species that contributed to the expansion rate. Observed ratios in ancient gas clouds match the values predicted by a hot origin with a specific baryon density. The consistency with microwave inferences reduces the room for exotic behavior at the largest scales. It also gives an indirect census of particles that barely interact with anything else. The observable universe tells not only where the edge lies, but what sort of ingredients filled the pot before any stars lit. Gravitational waves open a new channel, and even their current limits carry information. The absence of a loud stochastic background at certain frequencies constrains the violence of early phase transitions and the energy scale of certain inflationary models. Individual mergers of black holes and neutron stars serve as standard sirens, sources whose distance can be read from the waveform without reliance on intermediate calibrations. When paired with redshift information, these sirens write independent entries in the expansion ledger. The census of events will grow, and with it the reach of this method will extend across larger fractions of the visible volume. The edge becomes a little more transparent when space itself carries messages. He listens for whispers in the polarization again, this time for a curl pattern that would betray a background of primordial gravitational waves. No conclusive detection has appeared, yet the upper limits already prune ambitious models of the earliest moments. The absence of strong curls implies that if inflation occurred, it was either quieter than some versions predict, or dressed in dynamics that suppress such waves. The constraint narrows the stories one can tell about the prelude to the microwave sky, and therefore about the size of the region beyond our view that was once in contact. Topology leaves its own fingerprints, and the data have searched for them. If space wraps around in a compact shape, the microwave background might show matched circles with identical patterns, or large-scale alignments could hint at a preferred axis. Surveys have not found convincing matched circles, which pushes any non-trivial topological scale well beyond the observable diameter. Large-scale alignments have been reported and debated, and their statistical weight remains uncertain. If they are real, they could be the first hints of structure in the unseen, but they do not yet compel a revision of the broad picture. The caution here is part of the data itself. The sky offers anomalies at the edge of significance, and healthy skepticism keeps them as invitations rather than conclusions. He considers tensions that have emerged as measurements sharpen. The local expansion rate inferred from the distance ladder appears larger than the value extrapolated from early universe data under standard assumptions. The disagreement may point to unrecognized systematics, or it may be a sign that something in the late-time physics departs from the simplest model. Either way, the tension centers attention on the domain between nearby galaxies and the first light. New data will decide whether the difference is a mirage or a window. The edge here is conceptual. It is the boundary between a complete story and a story that needs a new character. A mosaic of all these findings gives a coherent portrait. The visible realm is large and nearly flat. Its structure grew from tiny ripples imprinted when the plasma was still tight with light. Those ripples evolved under gravity into a web whose statistics match what lensing and clustering reveal. The expansion history includes a recent acceleration that defines a horizon of fate in addition to the horizon of memory. The earliest episodes appear to have set conditions in a way that removes strong curvature and topological tricks from the accessible stage. Where the data invite speculation, they do so with narrow corridors rather than with open deserts. Even the anomalies are framed by precise numbers. He steps back from the figures and maps, and feels what the deeper investigation has given. It has reduced the freedom to dream irresponsibly, while expanding the power to imagine responsibly. It has replaced guesses about size and shape with constraints that guide even the boldest theories. It has turned the edge from a blurry suggestion into a finely contoured silhouette. The boundary remains a horizon rather than a wall, yet it now carries a pattern, a temperature, a polarization, a ruler, a census of elements, and a calendar of epochs. Data have not dissolved mystery. They have taught it manners and given it a voice. He notices that every success in measurement sharpens a new absence. The more precisely the sky is mapped, the more clearly it reveals what cannot be recovered. The expansion that carries galaxies apart does more than stretch wavelengths. It edits the record. Light from some regions will never arrive, and light from others arrives so diluted that it erases its own details. The archive of the cosmos is not closed, but it is incomplete by design. The puzzle shifts from where to look to what can be known at all. He studies how deep time hides causes behind effects. The early fireball left a background of microwaves with a near-perfect spectrum. That perfection is glorious and cruel at once. It confirms a hot beginning and smooth initial conditions while washing away specific memories of what happened before transparency. The signature tells that there was a conversation between matter and radiation, yet it tells it in a dialect that has lost its nouns. The line between inference and speculation becomes thin. He can hear the rhythm of the drum, but not the drummer who struck it. He learns the word cosmic variance and feels its weight. There is only one sky to observe at the largest angles. Statistical certainty requires an ensemble, but there is no ensemble to summon. The modes with the broadest reach are few, so their values carry large uncertainty that no new instrument can beat. Even perfect detectors cannot conjure extra universes to average over. This is a limit of principle that hides in plain sight. It means that some features in the oldest light can never be told apart from chance patterns, no matter how responsible or careful the analysis. He sees how the accelerated expansion tightens the noose on ambition. Regions that are visible today will fade beyond practical reach as their light redshifts into longer and colder bands. Spectral lines that once announced themselves will slide below any plausible detector, and structures that can be traced now will flatten into anonymity. In the far future, even the microwave afterglow will be diluted beyond recognition. The cosmos will seem younger to distant descendants simply because most of the evidence for its age will have been stretched into silence. The past can be lost in the very process that makes it visible today. He considers how the two horizons create a trap for curiosity. The particle horizon tells how far back sight can reach along the past light cone. The event horizon tells where replies can never come from. Between them lies a shrinking zone of negotiable contact. As acceleration entrenches itself, that zone does not just shrink in space, it shrinks in opportunity. Messages launched now will fall short of targets that already shine in our view. Some galaxies that write their light into our telescopes tonight would never hear from us, even if we replied at once. The romance of communication across the universe becomes a physics problem with a known solution, and the solution is refusal. He confronts the way gravity both reveals and confuses. Lensing lets mass be weighed without light, but it also tangles the information in every image. Magnification saves a faint galaxy from invisibility, while destroying an unbiased view of its surroundings. Shear patterns map total matter, while blurring the individual histories of the objects behind them. The same phenomenon that extends vision also distorts it. Untangling the distortion requires models that assume what is being sought. He realizes that evidence and interpretation are often entwined like vines on a trellis. The structure holds, but it is hard to say which vine shaped which curve. He tracks the path toward cosmic dawn and finds fog that is not only physical but logical. Neutral hydrogen absorbs and emits in a line that can map the era before the first stars lit the gas. Foregrounds from our own galaxy and from human technology drown that whisper by orders of magnitude. Subtraction can help, but subtraction is never perfect. At the same time, reionization itself hides the details of early structures by making the medium patchy and variable. Data arrive as a mixture of signal and screen. The first chapters of structure formation can be approached, yet they remain hard to read as a clean script. He asks whether the universe is truly flat or merely close enough to fool any finite survey. The current precision suggests flatness within small errors, but curvature could still exist on scales larger than the visible volume. If space curves very gently, the arc would be so broad that no measurement within reach could trace it. Topology plays a similar game. A space that wraps around with a period beyond the horizon would evade all circle matching tests. There is no magic instrument that can leap beyond the boundary to check. Geometry at the grandest scale may be a permanent ambiguity, preserved by the very rules that govern sight. He weighs the idea that the contents of the universe are not merely unknown in proportion, but unknown in kind. Dark matter is seen through gravity and not through light. Dark energy is seen through expansion and not through any interaction that can be tested in a laboratory. The first tells where mass hides. The second dictates how space grows. Both are inferred rather than directly handled. That alone would be unsettling enough. Added to it is the fact that if the expansion continues to accelerate, the laboratory of the cosmos becomes more sterile with time. Fewer mergers, fewer new structures, fewer violent events to probe fundamental physics. Nature appears to be turning down the volume on its own experiments. He notices tensions that resist an easy fix. Local measurements of the expansion rate and early universe extrapolations do not perfectly agree. Growth rates of structure inferred from different techniques show small but stubborn discrepancies. These may be the signatures of new ingredients or of new behavior in old ingredients, or they may be the fingerprints of subtle systematics. The deeper truth here is not which side will win. It is that some uncertainties sit at the crossroads between model and method. They may never be annihilated, only traded for others in a more refined description. Progress can be real while absolute closure remains out of reach. He turns to information itself and finds another cliff. If acceleration is here to stay, and if the background tends toward a de Sitter-like behavior, then horizons acquire thermodynamic meaning. A finite patch bounded by a horizon behaves as if it had a finite entropy. That suggests a cap on the total information accessible to any observer confined within such a patch. The limit is not just practical, it is conceptual. It implies that there may be truths that cannot be encoded within a single causal domain, not because they are mystical, but because the bookkeeping of quantum fields and gravity refuses to store them locally. He wonders about initial conditions with fresh humility. Models that explain smoothness and flatness often invoke a brief episode of extreme stretching in the early moments. That episode, if it occurred, can make the observable region a tiny speck of a much larger whole. It can also plant quantum fluctuations that look random yet are drawn from a specific distribution. The distribution can be tested, but the particular realization seen in the sky is only one roll of the dice. Some features are therefore accidents elevated by scale. Even perfect theory would not predict their exact configuration. Prediction gives way to probability, and probability can be satisfied by many outcomes. He finally confronts the vanishing of evidence as a future fact. Over immense durations, star formation will slow and cease. Black holes will evaporate, galaxies will cool, and the background of radiation will slide to wavelengths that overwhelm any finite detector. In such a future, the grand clues visible today will be gone. The ability to infer a hot origin, an expanding background, and a large-scale web will be denied to any late astronomer. Knowledge is time-stamped by the era in which it is sought. What can be known is not only a function of theory and craft, it is a function of cosmic weather. He accepts that the mystery deepens, not because the cosmos resists inspection, but because the rules of inspection include self-erasing chapters. Horizons expand yet deny access. Signals speak yet blur their own histories. Maps improve yet reveal statistical cliffs that cannot be scaled. The enigma at the edge is therefore twofold. There is an outside that cannot speak to us, and there is an inside that will gradually forget what it once heard. The task becomes one of using the privileged moment of clarity to ask the best possible questions before the dimming proceeds. The urgency is quiet, but it is real. It is written in the arithmetic of light and in the patience of space. He gathers the plausible shapes of the unseen and sets them on a quiet table. Each is a theory that asks to be judged by restraint as much as by reach. Each offers a different answer to what stretches beyond the edge of sight. No single vision is complete, and none can be accepted without tests. Yet together they form a map of possibility, a catalogue of destinies for the regions that no photon can deliver. One picture keeps to modesty. Space could be nearly flat because it is exactly flat, extending without bound, a Euclidean plane whose local ripples never sum to a global bend. In that case, whatever lies beyond the horizon is more of the same, a continuation of the web, its filaments and voids repeating statistically without limit. He knows this picture does not promise mirrored copies or tiled patterns. It promises randomness drawn from the same distribution, a quilt with no border. The virtue of this view is that it requires the fewest additional ingredients. Its challenge is that infinity is not a measurement. It is an idea given shelter by close to zero curvature. Another picture chooses curves and loops. Space could be finite by topology, even if its local geometry looks flat. A three-dimensional torus, for example, would mimic flatness over any survey smaller than its wraparound scale, and yet would fold back on itself over some immense distance. Beyond the horizon in such a world lie versions of the same cosmic web that are not copies, but continuations along a closed trajectory. He imagines light that once departed in a great circle, too long to complete, leaving only a suggestion in alignments too weak to convict. This path preserves parsimony while admitting a playful architecture, a room so large that its walls hide beyond reach. A third family of ideas opens the door to a different kind of beyond. Inflation, a brief era of accelerated expansion in the early moments, has the habit in many models of never truly ending everywhere. Regions stop inflating and cool to form pocket domains like ours, while other regions continue their rush, spawning new pockets without end. This eternal inflation builds a multiverse with a wild range of local conditions. Beyond the horizon in this case may lie not only more space, but other domains with different densities of dark energy, different particle masses, possibly even different effective laws within the same high-energy framework. The mechanism is sober mathematics, yet the outcome reads like a country of many laws. This view inherits a subtle burden. Predictions require a rule for counting outcomes in a setting where volumes grow without limit. The measure problem is the name for the difficulty of extracting probabilities when every possibility occurs infinitely often. Different cutoffs yield different forecasts for what a typical observer should see. He recognizes that this is not a small technical aside. It is the hinge on which the explanatory power of the picture turns. Without a principled measure, the multiverse risks becoming a generous excuse rather than a sharp instrument. Inside the same family lives the notion of bubble collisions. If neighboring pockets formed not too far away in the parent inflating space, they could have brushed against each other, leaving faint circular scars in the oldest light. The absence of decisive scars so far does not kill the idea, but it pushes the likely collisions beyond our screen or into parameter corners where signals hide. He keeps this possibility as a disciplined hope. A collision would be history written into the sky, evidence that the beyond is populated rather than empty. Quantum cosmology gives another route to a beyond that is not simply farther. The proposal known as no boundary suggests that at very early times the separation between space and time might blur, and the universe could be described by a smooth geometry without an initial edge. In such pictures, the horizon today is an artifact of later evolution, while the totality is a finite yet unbounded manifold. Hawking spoke of this with the calm of someone used to paradox. He was careful to note that such suggestions are not mystical erasures of cause, but alternative summaries of the same physics when extrapolated to regimes where classical intuition fails. There are models that trade the bang for a bounce. In ekpyrotic or cyclic scenarios, contraction precedes expansion, and the hot beginning is replaced by a transition that can leave imprints similar to those of inflation while arising from very different dynamics. If such a cycle occurred, the beyond might contain structures whose seeds were set by an episode before the last heating. The horizon would then be a veil drawn between two linked chapters. not a fence around a single episode. The merit of these ideas rests on their capacity to reproduce known statistics without fine-tuning, and on their ability to suggest features that distinguish them from their inflationary rival. String theory places a different kind of beyond on the table, a landscape of metastable vacua with diverse physical constants and particle spectra. Transitions among these vacua could be the engine of eternal inflation, with each bubble settling into one local minimum of a vast potential. The beyond, then, is a geography of possibilities. He approaches this cautiously. The landscape is a map with many pages missing, and its connection to observation remains indirect. Yet, it offers a candidate explanation for why parameters in our domain appear delicately balanced to permit complexity. Selection effects can be invoked, where observers arise only in bubbles with suitable conditions. Such reasoning is treacherous if it cannot be anchored to a predictive measure, yet it may be unavoidable if the landscape is real. Another thread recasts the border in terms of information. The holographic principle proposes that the maximum information contained in a region scales with its boundary area, not its volume. If horizons carry entropy proportional to their area, then the accessible patch to any observer might be fully described by degrees of freedom living effectively on its boundary. The beyond, in this telling, does not vanish. It is encoded, inaccessible in practice, but accounted for in the ledger. He is drawn to the economy of this principle. It unites gravity, quantum theory, and thermodynamics in a single triangle. Yet, translating its lessons from idealized settings to a universe with gentle acceleration is an unfinished task. There are bolder revisions that alter gravity itself on large scales. If the cosmic acceleration is not a separate energy component but a sign that the law of gravity changes beyond a certain length, then the horizon inherits new meaning. It becomes a scale where the familiar linkage between energy and curvature bends into a new relation. Modified gravity models attempt to preserve solar system successes while deviating only across cosmological distances. They must pass lensing and growth tests with the same parameters that fit expansion. If one of them survives, then the beyond is not another content but another rulebook, a shift in how structure responds to stress at immense scales. He also notes the quiet possibility that dark energy evolves rather than sits as a constant. If its pressure-to-density ratio changes with time, the event horizon can strengthen or weaken, and the far future can become more or less isolated. In some paths, acceleration fades, and distant realms that were destined for exile might again drift toward potential contact over unthinkable durations. In other paths, acceleration intensifies, and the fabric may tear in a remote catastrophe. The beyond, then, is a moving target shaped by a field that has not yet revealed its face. Each dynamical model is judged by its fit to the expansion ledger and to the rate at which structure grew. There is a more unsettling speculation that lives at the border of plausibility and paradox. In an infinite inflating ensemble, random fluctuations could assemble observers out of noise over eons, entities with fleeting memories that mimic genuine histories. If such Boltzmann brains dominate the head count, inference itself becomes suspect. To avoid this, a viable cosmology must make normal observers, born from stars and chemistry, overwhelmingly more common than these freaks. This requirement ties abstract measures to the credibility of experience. It turns the beyond into an ethical filter on theory. Do not populate the unseen in a way that undermines the trustworthiness of sight. He allows for the simplest answer to hold the throne while others compete in the wings. Perhaps the unseen is simply unremarkable. The same spectrum of fluctuations extended beyond reach, the same composition, the same calendar of structure formation, the same slow approach to a quiet, cold future. This is not a defeat for imagination. It is a recognition that extravagance requires evidence, and that absence of features where they could have shown is itself information. Yet he does not deny the lure of richer maps. Neighbouring domains with different constants could explain puzzling coincidences. A gentle positive curvature could close space on scales far beyond the radius of sight while remaining consistent with all present data. A faint scar from a primordial encounter could wait at the threshold of detectability. A dynamical dark energy could tip the balance of horizons in eras to come. A deep holographic description could reduce the apparent infinity of degrees of freedom to a finite alphabet on a distant screen. Each of these is an invitation, not a claim. He ends this catalogue with a rule of taste. Theories of the beyond must earn their poetry by passing through the narrow gate of prediction and restraint. They must reduce to the well-tested description inside the horizon. They must offer at least one path for falsification, and they must not multiply miracles only to hide them where light cannot reach. When they succeed, they change what the word beyond means. It stops being a void and becomes a structured possibility, a space where disciplined imagination can walk without losing the trail of evidence that made the walk meaningful. He studies the sky for the places where quiet breaks. In the smooth radiance of ancient microwaves, an expanse appears colder than statistics would suggest, a patch sprawling across a generous slice of the southern sky. It has been mapped by different instruments, processed with different methods, and still it persists, a basin in the temperature field known simply as the cold spot. He examines its shape and the ringed morphology that some filters reveal, watches simulations spin out thousands of random skies, and counts how often such a depression should arise by chance. The answer is not zero, yet the rarity is enough to keep curiosity awake at night. One proposal paints a supervoid along the line of sight, a region sparsely furnished with galaxies whose gravitational potential could drain a little energy from passing photons. Measurements of galaxy counts have hinted at a deficit, but the effect seems too weak to explain the full chill. The spot remains a rumor that refuses dismissal. Elsewhere, the largest angular features show a preference that feels impolite for a cosmos that is supposed to have no favorite directions. The quadrupole and octupole patterns appear aligned in a way that tempts the phrase cosmic axis. He resists slogans and asks for patience. Foreground removal is hard. Scanning strategies can imprint subtle striping, and minds are tuned to seek order. Even so, the alignments persist through different pipelines more often than a perfect null would allow. He does not rush to the banner of new physics. He tallies probabilities, corrects for a posteriori choices, and still finds a sliver of unease. If the alignments are real, they may hint at curvature or topology on scales larger than sight, or at relics of dynamics that slightly spoiled statistical isotropy in the earliest moments. A related whisper speaks of hemispheres with unequal power. When the microwave sky is split along a particular great circle, the variance of temperature fluctuations is marginally higher on one side than the other. The discrepancy is modest but stubborn under various cuts and masks. He connects it to models of dipole modulation, where a long wavelength mode modulates smaller scale ripples, creating a gentle gradient in strength across the sky. Such modulation could arise from physics that couples very large and small scales, perhaps through remnants of fields active near the beginning, or it could be a mirage born from chance alignment. The data do not confess, and so the anomaly sits like a door left slightly ajar. Parity adds another puzzle. When spherical harmonics are separated into even and odd sectors, the largest scales show a mild deficit of power in the even modes relative to expectation. The observation is delicate because the sample of modes at those scales is small, and chance can mimic pattern. Still, the repeated appearance of anomalies that all point toward unusual behavior at the largest angles creates a mood of accumulated doubt. He knows that correlation is not proof, that cherry-picking can coax a story out of noise, but he also knows that a responsible listener honors persistent motifs. He moves from the ancient background to the modern expansion and meets a tension that has sharpened with time. Independent measurements of cosmic distances that stack rungs from parallax to standard candles yield an expansion rate higher than the value inferred from early time parameters, projected forward in the simplest model. The difference is not an error bar brushing an error bar. It is a gap that resists reconciliation by minor tweaks. He inventories the possibilities. Hidden systematics in the ladder could masquerade as speed. Hidden systematics in early time calibration could masquerade as slowness. New physics could change the sound horizon or the growth of density before recombination, shifting the extrapolation while keeping the microwave map pristine. Each path has consequences that spill into other observables. He watches teams tighten calibrations, swap anchors, and cross-check with independent sirens. The tension remains an honest cliff. Growth offers its own disquiet. Weak lensing surveys that map the clumpiness of matter through shear sometimes prefer a slightly lower amplitude of fluctuations than the value implied by the microwave fit. The parameter that couples matter, density, and fluctuation strength appears to sag a little in late-time measures. The difference is not catastrophic, yet it rhymes with the expansion tension. If the universe expands a bit faster locally and clusters a bit less at late times, perhaps something in the recipe evolves. Or perhaps astrophysical effects that puff up the distribution of matter are more mischievous than expected. He does not jump to verdicts, but he keeps a ledger of whispers that slant the same way. Another subtle question arises from the smoothing of acoustic peaks in the microwave power spectrum by gravitational lensing. The inferred amplitude of this smoothing is sometimes a touch higher than expected. It is a tiny deviation, a parameter that nudges above unity, when unity would be harmony. Such a nudge can be an artifact of analysis choices, or it can be a hint that matter along the line of site clusters a bit more than the simplest model predicts. When this is considered alongside the lower growth suggested by lensing of galaxies, the chorus grows complicated. He accepts complexity as a sign that care is required, not as a license for speculation without breaks. He turns to the very low-frequency radio sky, where a claimed absorption trough in the global signal around cosmic dawn arrived deeper than most models anticipated. If the trough is real, either the gas was colder than expected, or the background radiation field was brighter at those wavelengths than the standard glow. New interactions that siphon heat from hydrogen have been proposed. So have populations of early radio sources that enliven the background. The measurement is demanding, the foreground's punishing, and replication is the adult in the room. The result remains an invitation to sharpen hardware and to deploy independent experiments that can confirm or rebuke the first report. Bulk flows on enormous scales have also been debated, with some analyses suggesting coherent motions of clusters over volumes where randomness should wash such patterns away. The measurements extract tiny kinematic signatures against a bright thermal foreground, and the uncertainties are intricate. Later studies have often softened the claim, yet the idea that matter might be tugged by structures beyond our current horizon has a gravitational plausibility that keeps minds engaged. If confirmed, such motions would be a local echo of distant mass, a way for the unseen to reach across with the long arm of gravity. Quasar groupings and giant alignments in radio polarizations have occasionally been offered as signs of coherence on scales that itch against standard expectations. Each claim triggers a cycle of scrutiny. Selection effects, survey footprints, and cosmic variance parade through the analysis. Some signals fade under the light. Others linger, weakened but not erased. He treats them as fragile fossils that might break under cleaning but might also be genuine bones of a larger beast. The only responsible posture is to refine data, increase sky coverage, and keep skepticism companion to wonder. He asks what all these anomalies could mean if they were not mirages. One family of ideas suggests that the early universe carried a slight violation of statistical isotropy, perhaps seeded by vector fields or by a subtle anisotropy during inflation. Such mechanisms can imprint preferred axes, dipole modulations, and parity quirks without wrecking the overall success of the standard picture. Another family invokes slight spatial curvature or large-scale topology that sits just beyond the range of circle matching tests, tilting the largest modes while leaving smaller scales untouched. A third points toward new light species or early dark energy that briefly altered the expansion around recombination, relieving tensions between distances then and distances now. He cautions himself that model building chases clouds if the clouds are shadows thrown by the same small sample sizes that plague the largest scales. He lists the ways the anomalies might dilute with improved control of foregrounds, with better absolute calibration, and with independent modes of observation. More satellites can map polarization with higher fidelity, ground arrays can refine lensing, radio interferometers can chart cosmic dawn with spatial detail that a global spectrum cannot provide. Gravitational wave sirens can trace expansion without reliance on standard candles or rulers, adding a clean rung to the ladder where the disagreement currently sits. A recurring lesson emerges from this inventory of disquiet. Anomalies are double-edged. They are either portals or mirages. If they are portals, they open into chambers where the beyond leaves fingerprints in the scene. If they are mirages, they warn of the traps that small numbers and complex pipelines set for honest minds. The only cure for both possibilities is the same: build redundancy, multiply channels, demand that hints cohere across independent domains. The sky rewards patience by turning rumors into facts, or by dissolving them into the useful residue of better technique. He returns to the cold spot, to alignments, to gradients, to tensions in expansion and growth, and he holds them together like stones in a palm. None compels a rewrite alone. Together they hum at the edge of hearing. They do not refute the broad canvas of a nearly flat universe seeded by early fluctuations and now driven by a gentle acceleration. They test its margins. They ask whether the largest scales whisper of influences that reside just outside the range of direct witness. He accepts that the best answer today is an honest maybe. The anomalies that refuse quiet perform a service. They keep the desire for deeper checks alive, they sharpen instruments and methods, and they invite new frameworks to step forward with predictions, not just stories. The horizon does not yield its secrets easily. It allows enough irregularity to provoke and enough regularity to restrain. The anomalies are thus teachers. They remind him that certainty in cosmology is always statistical and that humility is the proper posture when reading one's sky. They also suggest a promise. If any of these murmurs are real, they will grow louder in the next generation of maps and measures. If they are illusions, they will fade under the light of redundancy. Either outcome refines understanding. Either outcome honors the silence beyond by listening to the part that can speak with a more careful ear. He separates memory from possibility with careful geometry and watches two circles of fate appear in the same sky. One circle encloses everything that has already spoken. The other encloses everything that could ever answer. Their names are particle horizon and event horizon, and together they define the grammar of contact in a universe that expands. They are not objects. They are relationships between times, places, and the finite speed of signals. They turn the word beyond into two distinct questions. What has had time to arrive? What can ever arrive? He starts with a clean construction. Imagine an observer carried gently along the cosmic flow, seated in the rest frame where the microwave fog looks almost uniform. At a given cosmic time, he draws his past light cone. Every radius on that cone intersects earlier slices of time at a particular co-moving distance. The outermost intersection on the initial slice of transparency defines the particle horizon. It is the farthest co-moving shell that could have sent any photon that reaches him by the present moment. The proper distance to that shell today is larger than the naive product of age and light speed, because the fabric has stretched while messages were in flight. The particle horizon is therefore a bookend for history, not a fence in space. It expands as time accrues, admitting new chapters that were always there but had not yet arrived. Next he turns the cone forward. At this same moment, he draws his future light cone. Its interior marks places his signals can reach if sent now. The event horizon is the limiting co-moving radius of any world line that could ever reply. no matter how much time is allowed. If expansion accelerates in a sustained way, that radius is finite. There will be distant galaxies that can be seen today and yet can never hear from him. This second circle is a bookend for destiny. It may exist even when the first circle keeps widening. Time adds memories while subtracting opportunities. He sketches these relationships on a Penrose diagram, where the entire history of an expanding universe is compressed onto a compact diamond, so that light rays always trace 45-degree lines. In this picture, the particle horizon is the lower boundary of the diamond that can influence his current location. The event horizon is the upper boundary of the diamond that his current location can influence. The overlap is his causal diamond, the region that can converse. Outside one edge lie events he can witness but never visit. Outside the other lie places he could visit only if he had moved in the past. Outside both lies the unreachable and the unseen. The diagram does not moralize. It simply quantifies what stories can be exchanged. He inventories other horizons that often cause confusion and lines them up beside these two. The Hubble radius is the instantaneous scale at which co-moving recession equals light speed. It is a kinematic yardstick that does not fix memory or destiny. A photon emitted just beyond that radius can still enter as the radius grows during decelerating epochs. The apparent horizon is the surface on a given slice where outward moving light rays stop increasing their areal radius due to expansion. In many cosmologies, it lies near the Hubble radius. None of these equals the particle or event horizon, yet all of them foretell how signals navigate a changing scale factor. Knowing which horizon is being invoked is part of thinking clearly. He then gives the two circles texture by tying them to the cosmic recipe. During early radiation domination, the scale factor grows like time to the 1/2. During matter domination, it grows like time to the 2/3. During accelerated phases, it grows faster than any power law. In the first two eras, the particle horizon increases briskly and new territory becomes visible with each cosmic year. The event horizon does not exist in a strict sense when deceleration persists forever. In a late era of acceleration, the particle horizon continues to broaden its tally of the past, but an event horizon appears and freezes a ceiling on the future. The exact sizes depend on integrals over the scale factor that count photon steps and add them up with the correct weights. He conjures simple operational tests. Suppose a beacon in a distant galaxy flashes toward him now. If its co-moving distance lies inside his particle horizon at the next moment, a faint echo will eventually arrive. Suppose he flashes in reply without delay. If the galaxy lies inside his event horizon, the reply could reach it someday. If it lies just outside, the reply will fall short regardless of patience. This calculus can be symmetrized. An observer in that galaxy performs the same evaluation with his own horizons. Because the universal slicing is shared by all co-moving observers, both reach identical verdicts about whether they can ever converse. The verdict follows from geometry rather than from the strength of transmitters. He notes the practical poetry of communication in such a world. Messages sent to friends who live just inside the event horizon will arrive after centuries of travel, but still arrive. Messages sent to friends just outside will never cross an ever-widening gulf. There exists an optimal time to speak if one hopes to hear back from particular co-moving shells. The optimal time is now. Waiting tightens the noose, because accelerated expansion lengthens the track beneath every beam. The sky becomes a set of dwindling appointments that can be kept only if invitations are posted immediately. He brings temperature and entropy into the same conversation. In a space-time that asymptotically resembles de Sitter space, a static observer feels a thermal bath with a temperature proportional to the Hubble scale and an associated entropy proportional to the area of the event horizon. The association is not a metaphor. It is a calculation that pairs geometry with thermodynamics. The event horizon therefore acts as an information boundary. It hides degrees of freedom in a way that forces bookkeeping to count only what resides inside with weight given by surface, not volume. This is different from the particle horizon, which carries no such intrinsic thermodynamic identity. The two circles are siblings in the family of causal limits, yet only one wears a cloak of heat. He translates the logic of horizons into the language of experiment. When astronomers plan deep surveys, they are choosing which thin shell of the past light cone to anatomize. The particle horizon is the outermost shell that observation can sample in principle. When mission architects contemplate sending probes or signals into intergalactic space, they are choosing targets within a shrinking cone of possibility. The event horizon is the absolute edge of mission design, even for civilizations that endure beyond any realistic timescale. Strategy follows from causal maps, as surely as optics follows from mirrors. He takes a longer view and asks how the two horizons sculpt the experience of time for distant heirs. In a far epoch, the particle horizon will have included almost all of the co-moving realm that ever could have spoken. Yet the event horizon will have walled off the rest of creation so thoroughly that the sky will simplify to a small, locally bound neighborhood. The faint background that once shouted an origin story will have been stretched past utility. The two horizons then conspire to grant a temporary era of cosmological clarity, followed by a long winter of parochial skies. This is not melancholy. It is a precise forecast of how evidence decays when bounded by area and stretched by time. He entertains the thought of gentle changes to the expansion that would alter the balance. If the agent of acceleration were to evolve and fade, the event horizon could recede or disappear, and conversations postponed might again become possible in unimaginable futures. If the agent were to strengthen, the event horizon would tighten and the isolation would come sooner. The particle horizon would continue its slow growth in either case, but the catalogue of the reachable would swell or shrink accordingly. The shapes of these circles are thus not fixed forever. They are sensitive to the character of the pressure that fills space. He steps back from equations and names and lets the picture resolve. Two circles are enough to command a universe of meaning. One tells him what the present can hear, one tells him what any present can make happen. Between them lives the small diamond of reciprocity, where knowledge can travel both ways. To work within that diamond is not a limitation of spirit. It is the right scale for honest inquiry. It invites careful listening to the far past and quick speech toward the near future. It urges craft, not bravado. It teaches that the most human act in a cosmos with horizons is to coordinate curiosity with the geometry that governs every path that light can take. He imagines a field spread across the infant cosmos, a quiet slope with a shallow tilt. This field holds energy even when it barely moves. Energy curves space, and in this state the curvature is gentle and positive, driving an almost constant expansion that doubles distances with metronomic regularity. While the field lingers on the slope, space swells faster than any structure can assemble. Quantum fluctuations ripple the field, nudging it here and there. Most nudges are small. Some are large enough to halt the slide in local patches, keeping those places inflating while neighboring regions begin to cool. The result is not a single exit from a single sunrise. It is a quilt growing its own fabric, a self-reproducing stage, where expansion in the parts that linger outpaces the decay in the parts that finish. The field becomes a gardener that never stops seeding. He follows one patch that slips off the slope. When the field falls far enough, its pent-up energy converts into a hot bath of particles and radiation. This conversion is reheating. In that patch, expansion slows from near exponential to a gentler pace where gravity and pressure begin a competition that will later birth galaxies. To observers born in this reheated region, the hot beginning looks like a singular origin, yet the larger story is not a single opening act. Beyond their horizon, other patches still inflate, spawning further domains that will never be seen. The garden grows faster than any harvest. He then attends to the mechanics that make self-reproduction possible. The field evolves through two motions at once. A smooth classical roll drifts it downhill. Quantum jitters give it random steps up or down. Where the classical roll dominates, inflation ends in finite time. Where the random kicks compete successfully, the field loiters. In those loitering zones, space expands so quickly that even if many subregions tumble out and reheat, the remaining inflating volume grows overall. The statistics favor endlessness. There is no global clock that rings and calls the process to a halt everywhere. The frontier of inflation marches outward forever in expectation, like a shoreline that recedes as it is approached. He contemplates a different route to continuation. Instead of loitering due to jitters, the field may be stuck in a false resting place, a local minimum separated from a deeper trough by an energy barrier. Quantum tunneling can puncture a hole through the barrier, creating a bubble inside which the field can roll to the true valley and reheat. Outside the bubble, the false vacuum still drives swift expansion. New bubbles appear at random, each with its own interior history, each expanding at near light speed behind a wall of formidable tension. The outside expands faster than bubbles can fill it, so the sea of false vacuum never runs out. The picture is different in detail from the jittering slope, yet similar in consequence. Domains keep forming while the background keeps feeding them. Inside a freshly born bubble, the geometry settles into an open, negatively curved spacetime that quickly dilutes the curvature as particles fill the stage. That interior can host its own brief phase of slow roll to generate the near-scale invariant pattern of density ripples needed for galaxies. Thus, a single global process creates many local histories with compatible initial conditions for complexity. The seams between bubbles are forever out of reach for inhabitants, not because they do not exist, but because the background between them grows too quickly to cross. A domain wall is a history that cannot be visited. He examines what variety these domains might carry. If the underlying theory admits many valleys with different particle masses, interaction strengths, or residual vacuum energies, then each bubble may inherit a distinct set of effective constants. Some ranges of those constants permit long-lived stars and chemistry. Others do not. The distribution of domains becomes a catalogue of possible physics. He resists the temptation to call this an inevitability. It relies on the structure of the foundational theory and on the dynamics of vacuum selection, but it does sketch a possible meaning for what lies beyond sight. Not just more space, but other chapters in the rulebook, written by the same deeper grammar. The question of prediction rises like a tide. When every allowed outcome occurs in infinitely many places, how should one compute the probability of seeing any particular value here? A cutoff in time or volume biases the count, rewarding some histories over others. Different cutoffs give different answers. This is the measure problem. It is not a quibble. Without a principled measure, the framework can explain many things after the fact, but hesitates to make crisp forecasts. He listens to proposals that weight by observers, by pocket volumes corrected for expansion, by geodesic congruences, by entropy production. Each attempt reduces some paradoxes while planting others. He accepts that endless seams require an accounting method that does not yet feel final. Youth presents a paradox of its own. If volume grows fastest where inflation persists, most places in a naive counting are newly reheated and very young. Typical observers then appear uncomfortably early relative to many yardsticks, in tension with the large age needed for complex chemistry to flower. Measures that overproduce youth do not match a world filled with ancient stars and layered histories. Any acceptable rule for counting must tame this bias. The need to suppress a glut of fresh domains becomes a test as sharp as any fit to a spectrum. He turns from statistics to the intimacy of fluctuations. The same quantum jitters that breed self-reproduction also seed the structure of any one reheated domain. On scales much smaller than the global mosaic, the field's fluctuations leave nearly Gaussian marks with a spectrum close to scale free, bent slightly by the slope of the potential. That universality explains why different inflationary realizations can feed the same local observations. Many global quilts stitch the same local pattern. This duality is sobering. It means that measurements inside a single domain may never distinguish among the grander tapestries except through rare and delicate signatures. He asks what those signatures might be without trespassing into collisions. A small residual curvature could survive if the interior inflation was too brief, imprinting a gentle open geometry measurable in future surveys. Slight departures from exact Gaussian statistics could reveal interactions in the field or multiple fields at play, hinting at the shape of the potential. Long wavelength modulations of small-scale power could betray relics of pre-domain dynamics that leaked into the observable patch. Each clue is a narrow window. Each demands instruments of great finesse and skies mapped with patience. He pauses over the beginnings of the whole process. If inflation stretches everything, does it erase the need for a prior cause? A theorem rises in his memory that declares inflationary histories are incomplete when traced backward. They require an earlier stage or a different description before the stretching began. The endlessness is future-facing. The past remains a question mark dressed in mathematics. This is not a failure. It is a reminder that one successful mechanism does not answer every version of origin. The seams run to the edge of time in one direction and fade into uncertainty in the other. Thermodynamics also enters the hall. Regions bounded by effective horizons carry entropies proportional to their areas. As inflation continues in parts of the whole, new horizon areas blossom, increasing the total capacity for information. Reheating converts vacuum energy into particles and radiation, raising entropy further. The arrow of time looks secure, driven by a process that creates more room for counting and more degrees of freedom to count. Yet the bookkeeping raises new puzzles about unitarity and the ultimate fate of information in a space-time with proliferating horizons. He does not pretend to solve these puzzles. He lets them stand as reminders that global growth has quantum costs. He then returns to the human scale of inference. If the larger reality is a mosaic of domains, our data give a local weather report in one tile. The ambition is to let that report constrain the climate of the whole quilt. That ambition is not empty. The near-scale invariance of structure, the uniform glow of ancient radiation, and the late-time acceleration limit the kinds of inflation and reheating that could have occurred. They truncate the menu of potentials and dynamics. If a consistent measure emerges, it could turn the catalogue of domains into a predictive tool that explains why certain values here are probable rather than mysterious. Finally, he gives the picture a plain image. A needlework grows on an unending canvas. Stitches sprout new islands faster than the completed embroidery can cover the cloth. In each island, a distinct motif plays out. Yet to an ant walking on the fabric, the world looks complete and solitary. The ant charts its skies, measures its distances, and writes its physics with courage. It cannot step off its patch, but it can infer that the stitching continues past sight, guided by rules it has already learned. The seams do not belittle the patch. They dignify it by placing it within a craft that never repeats itself exactly and never stops. He considers the possibility that somewhere on the larger stage two young domains brushed like soap bubbles in a basin, their rims touching for an instant before drifting apart. If such a meeting occurred near the region whose fossil light now reaches his instruments, a faint bruise could linger on the sky. The bruise would not be a crack or a crater. It would be a disk of gentle contrast, almost circular, with a temperature pattern that slides from warm to cool across its face and a sharpness near its boundary that is hard to mimic with ordinary noise. The physics behind the mark is simple to sketch. A neighboring domain advances. A wall separates equations of state. The encounter perturbs gravitational potential and motion, and passing photons inherit a whisper of that disturbance. The result is an imprint that respects axial symmetry while bending the statistical rhythm of the background. Polarization would carry an echo of the same disturbance. Where temperature draws a smooth disk, polarization might sketch concentric rings. A delicate fringe, caused by the way last scattering, responds to a tidal nudge. The pattern would be faint and spread over degrees of sky, too soft to find by eye, yet crisp enough for algorithms designed to weigh every pixel without prejudice. He imagines a search that slides circles of many radii across the celestial sphere, fitting a simple profile with few parameters: center, radius, amplitude, orientation. The scoring is statistical, not narrative. Peaks in the score identify candidates that pass from rumor to inspection. Such a collision, if real, must also fit into the ledger of expansion. The encounter should not ruin the remarkable uniformity of the ancient glow outside the disk. It should not bend large-scale geometry beyond narrow limits. It should not overproduce curvature, generate violent gravitational waves in forbidden frequency bands, or leave a wall of exotic matter speeding through the local cosmos. The theoretical paintbox has constraints: thin wall approximations, gentle vacuum contrasts, modest relative velocities. He finds that a wide swath of parameter space can satisfy these demands while still leaving a visible scar, but only barely visible. The universe protects its continuity by making dramatic encounters rare or lightly inked. He turns to the practical craft of looking. Data pipelines begin with cleaned maps, where our galaxy's dust and synchrotron hum are peeled away with care. Beam asymmetries and scanning footprints are modeled, then filtered. A catalogue of masks excises bright sources and the crowded plane. Over the remaining canvas, circles are tested in great number. For each circle, a smooth temperature template is compared to the sky. The likelihood that chance alone could produce a better fit is computed through simulated skies drawn from the same statistical distribution that best describes the undisturbed background. Only circles that outperform almost all of these trials earn attention. For the most promising, polarization templates are matched in tandem, seeking the predicted ringed fringe that lends credibility to the temperature signal. The method cannot be guided by hope. Once the template family is chosen, the test must run blind. He notices that a real collision would not simply imprint one disk and depart. It would also nudge velocities within the disk, inducing a modest Doppler tilt that adds a gradient across the temperature field. It might shift the phase of acoustic peaks within the affected region, subtly changing the way power is distributed over angles. Galaxy counts, if deep enough and wide enough, could share the same modulation at later times, because the original perturbation would seed a very long wavelength fluctuation in density and flow. A convincing case would therefore stitch together signatures across multiple traces: temperature, polarization, lensing convergence, and perhaps the mildest of flows in the distribution of galaxies. He reflects on another channel for memory. At the moment of encounter, the wall that divides the two domains could emit a short burst of gravitational waves. The burst would be broadband and weak, its frequency set by the scale of the collision and its amplitude suppressed by the smallness of the energy difference that allowed both domains to survive. Direct detection is unlikely, yet such waves contribute to a background that might one day be surveyed across frequencies from space-based interferometers to pulsar timing arrays. The absence of a strong background already herds theory toward gentler collisions. Memory can be written by silence as well as by scars. There is also the possibility of multiple encounters. If the surrounding landscape contains many valleys with similar depths, a young domain could be jostled more than once during its early growth. The sky would then hold several disks, perhaps overlapping, perhaps at different scales. The statistics of such multiplicity would be a demanding test. Pure chance rarely arranges several coherent circles, with the right correlated polarization in independent patches. Yet the same caution applies. Selection effects can invent patterns out of enthusiasm. Searches must penalize extra freedom in models that allow many disks and guard against fitting away random bumps with a flexible hand. He asks whether any other known process could convincingly mimic the target. Supervoids along the line of sight can produce cold regions through the integrated Sachs-Wolf effect, but their influence is typically shallow and broad, lacking the sharp boundary and coordinated polarization expected from a collision. Residual foregrounds can paint spurious features, yet careful frequency scaling and cross-checking between independent instruments suppress this danger. Beam systematics can lure the unwary, but they tend to imprint symmetries tied to scan strategy rather than to the simple axial symmetry of a disk that knows nothing of spacecraft motions. Each counterfeit has a tell. Robust searches use those tells to keep temptation at bay. He contemplates the philosophical weight of a positive detection. A single well-supported disk, confirmed in temperature and polarization with parameters that cohere across maps and methods, would elevate the idea of neighboring domains from possibility to inference. The local sky would become a historical document that includes an entry from outside its own causal seed. The beyond would move from proposition to event, yet he also accepts that even a detection would not unfold the full narrative. The external domain's detailed physics would remain hidden behind the same accelerating expansion that keeps all distant regions at arm's length. What would be granted is not a tour, but a footprint at the door. Negative results carry their own meaning. To survey the full sky at high fidelity and find no credible disks within defined thresholds of amplitude and size is to push the rate of such encounters lower and lower. The allowed space of theories that produce frequent or strong collisions would be choked. Cosmology would still admit other kinds of beyond, but the kind that leaves circular bruises would be relegated to the margins. Discipline resides in ruling out as much as ruling in. He sees the virtue in that equilibrium. A map that shows no scars is not a disappointment. It is a constraint written in the simplest ink. There is an aesthetic that guides the search as much as algebra does. The sort signal is humble, almost shy. No jagged edges, no spectacular spirals, only a disk that looks simple enough to be overlooked. That simplicity is a gift. The fewer the parameters, the stronger the statistics. The more symmetric the profile, the harder it is for messy systematics to counterfeit. The test asks for patience rather than brilliance, for coverage rather than flourish. It asks for multiple teams to try, fail, refine, and try again without attachment to outcomes. He lets the scene resolve into a final image. A quiet circle, barely different from its surroundings, sits on a sea of random ripples. Its edge is just a little too sharp. Its interior is just a little too tilted. Its polarization is just a little too ringed. Alone, each deviation could be a coincidence. Together, they form a sentence that can be read. The sentence says that somewhere, early and far, a neighbor pressed a palm against the same fabric for a fleeting moment and then withdrew. If that palm print exists, it will not be dramatic. It will be a courtesy note from the outside world, written softly enough to honor the smoothness of the sky that carried it. He turns the edge into arithmetic and watches space transform into a ledger. The hint arrives not from a distant galaxy, but from a darker teacher. A black hole swallows matter and light with equal appetite, yet it refuses to hide all evidence of the feast. Its entropy is not proportional to the volume within its horizon. It is proportional to the area of that horizon measured in units of the Planck length squared. Area divided by 4, multiplied by the fundamental constants, yields a number that behaves like a count of microstates. A surface, not an interior, holds the bookkeeping. Temperature joins the lesson when a black hole emits a thin thermal glow called Hawking radiation. The glow is faint, yet its existence turns a gravitational boundary into a thermodynamic membrane. The horizon is warm. Warmth implies microstructure. Microstructure implies information. He follows the implication to a broader rule. If a region bounded by a horizon carries entropy proportional to area, then the maximal information storable in that region scales with the boundary, not the bulk. This is the holographic principle. It is a claim about how many distinct states can be told apart by any observer confined within the region. It does not say that the interior vanishes. It says that the interior could be fully encoded by degrees of freedom, effectively living on the boundary. The name is a metaphor that became a method. A three-dimensional scene can be projected onto a two-dimensional plate without losing content. Gravity seems to demand a similar economy at the deepest level. He asks whether this economy is a curiosity of black holes or a signature of spacetime itself, another horizon answers. In a universe with persistent acceleration, there exists a cosmological event horizon with its own temperature and entropy. An observer who waits forever perceives a thermal bath with a temperature set by the expansion scale and an associated entropy proportional to the horizon area. The parallel is too pointed to ignore. It suggests that any observer in such a world lives inside a finite information budget. The edge becomes a screen that tallies what can ever be learned. The ledger exists even if one never touches the boundary. A proof of concept derives from a geometry that is easier to tame than a cosmological one. In a space-time with constant negative curvature, a precise duality relates gravity in the bulk to a quantum field theory without gravity living on the boundary. The bulk is a theatre where geometry bends under stress. The boundary is a stage for particles and fields governed by the iron rules of quantum mechanics. The two descriptions produce the same correlators, the same spectra, the same thermodynamics. This is not a loose analogy. It is an equality between theories built in different languages. One can compute a thermal entropy in the boundary theory and read it as the area of a black hole in the bulk. One can add a small deformation on the boundary and watch the interior respond with a shift in geometry. A dictionary translates states to shapes, operators to surfaces, entanglement to areas. Gravity becomes an emergent account of how information organizes itself on a lower dimensional screen. He lets the most striking line of that dictionary settle. The entanglement entropy of a region in the boundary theory is given by the area of a minimal surface in the bulk anchored to the region's edge. The formula is geometric and quiet. It ties quantum correlation to shape. As the boundary state changes, the network of minimal surfaces threads the bulk in new ways. The bulk volume can be viewed as a measure of complexity, a resource that grows as the boundary state is built by deeper circuits. Lines of research dress this imagery with rigor. Tensor networks tile a disk with nodes and bonds to mimic how entanglement weaves space. Error-correcting codes emerge as models where bulk information is redundantly stored in many disjoint boundary regions, making geometry robust against local erasures. These are not final answers, yet they deepen the intuition that space itself may be a tapestry woven from entanglement. He asks how this boundary logic reframes a cosmological edge. The universe that accelerates resembles a space-time with positive curvature, not negative, and the precise dualities are less complete there. Still, the thermodynamic similarity of horizons invites extrapolation with care. An observer's causal patch may admit an effective holographic description in which the event horizon encodes the accessible degrees of freedom. If so, the limit on what can be learned is not a soft cultural boundary. It is a cardinality bound on the Hilbert space available to the observer. That bound grows as the horizon area grows, and then plates out when acceleration becomes dominant. Curiosity would then possess a literal budget in bits, growing through epochs of deceleration and leveling in the late Quiet Age. He recognizes that information is not merely counted, it must move under rules that preserve unitarity. Black hole evaporation sharpened that demand by presenting a paradox. The thermal nature of the glow seemed to erase correlations and to turn pure states into mixed ones. Resolution has gathered around a page curve that bends back toward purity when quantum extremal surfaces are accounted for. The lesson, again, uses areas as bookkeepers. New surfaces enter the tally at late times and redirect entropy flow in a way that restores unitarity. If this logic generalizes, then cosmological horizons may require similar extremal surfaces to account correctly for the flow of information in an expanding universe. The mathematics is young in that domain, but the principle is provocative. The boundary is not static. It participates in the accounting as time unfolds. He tests the principle against operational thought experiments. Two observers who share entanglement and then separate toward their respective horizons lose access to joint operations as the horizons tighten. The shared entanglement becomes a resource that cannot be fully recovered once the horizons break their common past. If the holographic accounting is right, The loss is not destruction, but sequestration on distinct screens. Complementarity offers a way to think without contradiction. No single observer ever witnesses a violation of quantum rules. Yet different observers may produce mutually incompatible global stories because they cannot compare notes across the barriers. The ledger remains consistent within each causal patch, and physics promises consistency where records can be brought together. He asks whether the principle can make contact with data. Indirect tests already exist when the boundary recipe in the negative curvature world reproduces thermal and transport properties measured in strongly coupled materials. The duality becomes a computational engine rather than a distant parable. In cosmology, the tests are more conceptual. If holographic bounds are sharp, then certain extreme densities of information should be forbidden to accumulate in a finite region for long. Early universe scenarios must respect these caps while generating the observed spectrum of fluctuations. Constraints on primordial correlations, on non-Gaussianity, and on the allowed complexity growth of states across epochs can be phrased as shadow consequences of a finite ledger. The program is to translate the poetry into inequalities that real skies can probe. He lets another interpretive thread through. Geometry may be the macroscopic face of entanglement, and locality may be an emergent habit rather than a fundamental axiom. If so, then what looks like an edge is a contour line in a field of correlations. The border around an observer is where the ability to reconstruct interior operators from boundary data abruptly fails. Entanglement wedges then define what parts of the interior are knowable from given boundary regions. The wedges expand when correlations are strong and contract when they weaken. In a late accelerating era, wedges shrink for distant regions, and the reconstruction power of any single observer narrows. The picture is sober rather than mystical. It offers a precise translation between knowledge, correlation, and shape. He keeps his criticism awake. The most refined dualities are built in settings that do not match the global character of observed space. The dictionary to a realistic accelerating world remains under construction. Positive curvature does not yield the same clean-cut conformal boundary that negative curvature does. Proposals for a static screen or a late-time boundary that captures the physics of an accelerating patch carry ambiguities, yet the persistence of area laws and of thermodynamic behavior at horizons argues that the core lesson survives translation. Information counts by surfaces. Gravity is a guardian of that accounting. He returns to the beginning of the thought. If the edge is a ledger, then the question what lies beyond can be reframed. The beyond may not be a warehouse of additional stuff to be found. It may be the part of the ledger that cannot be read by a given observer because the relevant columns live on a screen forever out of reach. In this view, the unseen is not unmodelled. It is encoded in degrees of freedom that do not commute with the ones inside the patch in a way that allows reconstruction. The humility required is technical. One must accept that the world is complete without being fully accessible from any single vantage. He sets down the idea with care. A boundary that radiates, that tallies, and that entangles is not merely a line on a diagram, it is a participant in the theatre of information. It warms the vacuum, it caps the census of states, it translates geometry into correlation. Treating it as a ledger does not shrink the world. It enlarges the meaning of seeing by reminding the watcher that every image is already a computation performed across a screen that both reveals and withholds. The edge keeps secrets, but it keeps them honestly. With a balance sheet anyone can audit if they remain within their patch and let surfaces do the counting. He gathers instruments like new senses and sets them listening where light grows thin. Photons have served faithfully, yet they carry a memory that begins only after the fog of charged particles cleared. Earlier chapters were written in other messengers. To reach them, engineers carve delicate antennas, chill detectors to quietness, and teach algorithms to hear whispers that space has been saving since the first breaths of time. The plan is simple to state and hard to execute. If light cannot report, listen for the longer waves of neutral hydrogen, the tremors of space-time itself, and the silent clocks inside nuclei that keep the ages of stars and galaxies. Each messenger is imperfect alone. Together they promise a biography of the edge that light could not cross. He starts with the 21-centimeter line, the spin flip of neutral hydrogen. Before stars lit the gas, the universe was filled with hydrogen that could absorb or emit at this frequency. Expansion stretched the line to meter and meter-scale wavelengths, a band where the sky is loud with human noise and with the low rumble of our own galaxy. The desired signal is 1,000 times fainter than the foreground. Yet it is structured in a way that foregrounds are not. Foregrounds are smooth in frequency. The cosmic signal varies with redshift because the conditions of the gas changed as first light bloomed. In that difference lies the chance for separation. Single dipoles try to measure the global average, a broad trough and peak in the sky average spectrum that tell when the first sources heated and ionized the gas. Arrays of hundreds and thousands of antennas try to build images by using Earth as a giant lens, cross-correlating signals to reconstruct a three-dimensional map of neutral hydrogen across time. He imagines success. A tomographic movie of cosmic dawn would show islands of ionization swelling around the earliest galaxies and black holes. It would reveal temperatures of the intergalactic medium, the efficiency of heating by X-rays, and the timing of the percolation that turned fog to clarity. It would also carry the fingerprints of the very first fluctuations on scales far beyond those probed by galaxy surveys. The brightness temperature maps would be sculpted by the same density ripples that later formed filaments and clusters, only less contaminated by non-linear growth. Calibrated carefully, those maps could refine the ruler set by acoustic waves and read the expansion history with a new alphabet. He follows the radio waves to lower frequencies and longer baselines, where the foreground wedge in Fourier space threatens to swallow the signal. He watches statisticians carve a clean window above the wedge and collect power spectra rather than images, a compromise that still carries meaning. He sees clever tricks that use redundancy in array layouts to self-calibrate when bright sources refuse to sit still. He sees night after night of integration that trades time for depth, and remote deserts turned into observatories because human transmitters must be kept far away. The patience demanded is not theatrical. It is the cost of hearing a whisper beneath a choir. He then attends to another messenger that does not care about fog. Gravitational waves pass through plasma as if it were a dream. If violent processes in the first fractions of a second stirred spacetime, a background of ripples could still be traveling. The spectrum is a mosaic of possible sources. Phase transitions in fields could have bubbled and collided. Cosmic strings could have snapped and reconnected. Inflation itself could have left a nearly scale-free bed of long waves. Different instruments listen to different octaves. Ground-based interferometers catch the chirps of compact mergers today and set upper limits on any loud primordial hum in their band. Space-based interferometers promise access to lower frequencies where galactic murmurs and hypothetical early phase transitions might sing. Timing arrays that use millisecond pulsars as metronomes already hear a nanohertz chorus from the slow dance of supermassive black holes. If a primordial note lurks nearby, it would tilt that spectrum in a way that careful modeling could expose. He considers a quiet a sign, not a tone, but a pattern in light from the last scattering. Primordial gravitational waves would twist the polarization of the microwave background into faint curl patterns. Telescopes in cold, dry air scan the sky at multiple frequencies to separate those curls from the dust and synchrotron swirls of our own galaxy. They modulate beams to suppress systematics, rotate half-wave plates, and co-add years of data. The target sits below the level already constrained by temperature maps and by the absence of strong non-Gaussianity. Delensing algorithms remove the false curls induced by gravitational deflection to reveal what remains. If the signal is found, its amplitude would measure the energy scale of the earliest moments in a way no collider can. If it remains absent, the space of allowed histories tightens, disqualifying steep potentials and noisy fields. He shifts to standard sirens, a new rung on the distance ladder. When two neutron stars spiral inward, the waveform encodes their orbital dance. From the shape and loudness of the wave, a distance can be read without any brightness calibration. If a telescope catches the afterglow and identifies the host galaxy, a redshift can be paired with that distance. One event offers a rough measure. Many events across redshift build a curve that traces expansion. The method is immune to some systematics that haunt light, though it has others, such as inclination, degeneracies, and weak lensing that magnifies or demagnifies the signal. With volume and careful modeling, standard sirens can arbitrate tensions in cosmic speed and map the whisper of acceleration without relying on candles or rulers. In the future, black hole sirens with statistical host associations could increase the reach even when light remains shy. He adds spectral distortions of the microwave background to the tool chest. The average spectrum is an astonishing blackbody, yet small energy injections after the first few months of cosmic time would wrinkle it into a shape slightly off from perfection. Compton scattering at later epochs makes wide distortions. Damping of small-scale fluctuations and other early processes make mu distortions. A spectrometer with sensitivity orders of magnitude better than predecessors could detect these wrinkles. Each wrinkle would be a diary entry from an otherwise mute era, recording the dissipation of tiny ripples, the decay of relic particles, or the gentle build-up of structure. Distortions would not draw a map, but they would write dates and amounts into the history of heating and mixing. He turns to intensity mapping beyond hydrogen. Instead of cataloguing individual galaxies, he imagines sweeping the sky in bright emission lines, stacking their blended glow into low-resolution cubes of frequency and angle. Lines like carbon-2, carbon monoxide, and Lyman alpha trace star formation and gas across wide epochs. Cross-correlating these maps with galaxy catalogues and with lensing convergence removes interlopers and isolates the signal. The technique trades sharpness for reach, allowing vast volumes to be surveyed quickly. It is a cartography of averages that still knows where the ridges and valleys lie. Combined with hydrogen maps, it becomes stereoscopic vision for the young universe. He remembers that some of the most incisive tools are particles that rarely speak. Neutrinos decoupled when the universe was seconds old. Their background bath cools and thins, almost impossible to detect directly. Yet their presence is felt in the suppression of small-scale structure and in the phase of acoustic oscillations. Precision measurements of clustering and of the microwave background already weigh the sum of their masses as a global parameter. Should a detector one day count relic neutrinos by capturing them on special targets, that count would be a handshake across 13 billion years. Even without direct detection, the constraints they impose are a kind of hearing beyond the light horizon, because they fix conditions in an era when photons were trapped. He adds clocks carved from stellar spectra. Massive galaxies age their stellar populations in ways that can be read from features in their light. Differences in age between similar galaxies at different redshifts act as cosmic chronometers, measuring how fast time stretches between slices of the past. The method has uncertainties in modeling star formation histories and metallicities, yet it offers an independent derivative of the expansion history. When combined with rulers and sirens, it strengthens the weave of inferences about the scale factor's path, and therefore about the future reach of signals. He balances the excitement with realism. Every method is haunted by foregrounds, calibration drifts, and selection effects. Hydrogen maps must master ionospheric fluctuations and polarized leakage. Polarization searches must model dust grains that align in interstellar magnetic fields. Sirens must correct for inclination and for waves lensed by cosmic structure. Spectral distortion missions must stabilize detectors at an almost ascetic level and carve out systematic baselines that do not masquerade as cosmic wrinkles. Yet the redundancy across messengers is the cure. If independent paths converge on the same expansion history, the same growth rate, the same absence or presence of primordial waves, then confidence grows not by rhetoric, but by recurrence. He sees a future architecture emerge, Radio forests on quiet plateaus listen for hydrogen. Cryogenic telescopes on high ice chase curls in polarization until the sky yields or the models do. Interferometers in space draw triangles millions of kilometers wide to listen for the soft thunder of black hole pairs and the remnants of early phase changes. Wide-field spectrometers drift through the far infrared to chart the blended glow of star formation when galaxies were small. Networks of seismic isolation and laser light stretch their arms for chirps that turn distances into music. All of it funnels into a joint inference engine that respects causal limits while exploiting every indirect tell that nature offers. He lets the promise settle into a single thought. The edge is not merely where sight ends, it is where method multiplies. By shifting messengers, by lowering frequency, by reading strain instead of flux, by counting wrinkles in a nearly perfect spectrum, and by using standard sirens that do not care how bright their hosts are, curiosity learns to triangulate the unseen. None of these tools breaks the rules of horizons. They honor them and work within them. They turn the quiet beyond into a set of constraints that grow tighter with every season of listening. If patience holds, the next chapter's written by hydrogen, by polarization curls, by ripples in space-time, and by the faintest deviations from a perfect blackbody, will tell more about what lies outside the circle of light than light alone ever could. He opens atlases that do not look like books. They are mosaics of sky positions, redshifts, and shapes, stitched into volumes where every point is a vote for mass. Photons from distant galaxies arrive stretched, skewed, and dimmed by the invisible scaffolding between source and eye. From those distortions, he drafts maps of matter that never learn to shine. The craft is called weak lensing, and its signature is a coherent whisper, tangential alignments around heavy structures, correlated shears across degrees of sky. With billions of galaxy shapes and careful control of optics and atmosphere, the shear field becomes a landscape. Hills are halos, valleys are voids. The map is not a picture of the present alone. It is an overlay of histories, integrated along sightlines that cross most of cosmic time. Another atlas uses the light of galaxies as ink, but refuses to be distracted by brightness. Redshift surveys fill three-dimensional boxes with millions of points, then compute how often pairs are separated by a given distance. The pattern is not uniform. A faint bump appears at a special scale, a memory of sound waves that once travelled in the early plasma. Recovered as a standard ruler, that bump draws contours of geometry and expansion across the boxes. Densities and peculiar velocities leave their own marks. In one direction along the line of sight, galaxy positions are squashed or stretched by motion, a systematic anisotropy known as redshift space distortion. That anisotropy measures the rate at which structure grows. The atlas is therefore both a map and a meter. It charts where matter went and how quickly gravity herded it. He layers these atlases. Lensing counts total mass, luminous or not. Clustering counts traces that live in halos. Cross-correlations reveal bias, the factor that converts tracer density into mass density. Where galaxies overrepresent, bias is large. Where they underrepresent, bias is small. Calibrating bias lets the clustering map speak the language of mass. Calibrating shear measurements with image simulations and stellar reference fields trims systematic edges from the lensing map. When both are tuned, a third surface emerges, the convergence of mass along the past light cone as inferred from distortions in the microwave background. Ancient photons act as backlights for the entire web. Cross-correlating galaxy positions with this backlight confirms the kinship of structures separated by billions of years. He then consults a kind of mapping that does not resolve individual galaxies at all. Intensity mapping sweeps large areas in specific emission lines and treats each pixel as the sum of many faint sources. The result is a low-resolution cube whose axes are frequency and angle. From the cube, one can read the undulating pattern of large-scale structure without the penalty of catalogue building. The price is confusion from interloper lines and foregrounds, a price reduced by cross-correlation with surveys at other wavelengths and by the distinctive way cosmology imprints anisotropy between radial and transverse directions. The method is young and unsentimental. It trades detail for scope, then buys back detail by combining maps that share the same underlying field. He learns to read the edges of maps as carefully as their centers. Any finite survey sits inside a window that excludes modes larger than itself. Those missing super-survey modes still influence what happens inside, modulating the apparent clumpiness and shifting the measured amplitudes. The phenomenon is known as supersample covariance. It is not noise in the ordinary sense. It is the tug of structures too large to be charted directly. By modeling that tug through the separate universe approach, where a long wavelength over density is treated as a local change in curvature and expansion, one can calibrate estimators that are less fooled by the missing outskirts. In this way, the absent threads speak through tension on the ones that remain. He finds that voids carry as much instruction as clusters. Regions with fewer galaxies than average are not empty. They are puffs of the web where expansion has won against collapse. Their shapes, alignments, and lensing signals respond sensitively to the background expansion and to the way gravity behaves on large scales. Stacking many voids and measuring the slight demagnification and radial shear they impress upon background galaxies gives a clean test of geometry and growth. Voids are quiet laboratories. Their waters are less churned by the astrophysics that complicates dense regions. They write legible notes about the rulebook that guides the entire texture. Another script is drafted by Time. With a technique called reconstruction, he takes the present distribution of galaxies, divides out the coherent flows that have smeared structures, and partially restores the sharper features that existed when matter was younger. The standard ruler grows clearer. Phase information in the density field becomes crisper. The process is reversible only in part, yet it recovers lost contrast and tightens distance measures. Time is persuaded to give back some of what nonlinearity had taken away. He gathers these pieces into Bayesian engines that can infer not only the map that is, but the map that was likely to have been. The algorithms propose initial conditions drawn from a prior consistent with the spectrum of primordial fluctuations, then evolve those conditions forward under gravity and compare the result to the data. Accepted proposals are those that match while respecting observational masks and noise. The output is a family of plausible histories that converge on a shared past where the data are strongest. Such reconstructions embed the observable slice in a volume of likelihood, a context that extends beyond any single catalogue. They are not fantasies. They are constrained simulations that obey both the equations of motion and the facts of sight. Edges become opportunities for diagnostics with an older test. The Alcock-Pazinski effect compares observed radial and transverse scales of features that are intrinsically isotropic. If cosmological parameters are chosen incorrectly, isotropy is broken artificially. Applying the test to ensembles of voids, to the standard ruler, and to the shape of clustering provides a geometric check that does not rely on brightness or masses. It is a ruler encoded in symmetry rather than in light. He watches flows turn into compasses. Beyond the redshift rack, galaxies carry peculiar velocities that perturb their apparent distances. By measuring distances independent of redshift for a subset of objects, one can map these flows directly. Coherent streaming toward overdensities and away from voids tests gravity's pull. On very large scales, hints of bulk motion have been debated. Whether or not those hints survive, the technique itself builds a velocity field that complements density. Another way the invisible teaches through motion. He accepts that every atlas carries scars from instruments and atmosphere. Shapes are altered by seeing and optics that must be deconvolved. Photometry drifts with air mass and detector response, imposing spurious gradients. Redshift errors blur structures. Foregrounds leak polarized light into temperature maps. To live with these scars, surveyors design rotations, dithers and calibrators then simulate the entire pipeline end to end. They cultivate the habit of null tests that should yield nothing if all is well, and they celebrate failures because failures expose the next correction. Cartography here is as much about subtracting the world as it is about adding the sky. The atlases evolve with new instruments that widen and deepen. Larger mirrors feed cameras with more pixels and smaller noise. Space platforms escape atmosphere and see the same patch for years without blinking. Spectrographs place thousands of fibers on galaxies at once, gathering redshifts in a nightly harvest. Radio arrays fan out across planes, linking dishes into baselines that mimic a single immense eye. Each generation doubles the number of tracers, halves the uncertainties, and adds independent ways to cross-check. The progress is arithmetic and architectural at once. He steps back from the screens and sees what all these maps imply about what cannot be drawn. The tapestry shows filaments that curve toward a horizon where the weave fades. The statistics inside the window demand companions outside. Power on scales larger than the survey window leaves fingerprints on the covariance. Gentle tilts in the largest modes suggest that there are gradients whose crests lie beyond the border. Lensing of the microwave background by intervening mass proves that the web continues past the last bright galaxies toward epochs where starlight is scarce. In each case, the testimony is internal. The unseen is inferred because the scene behaves as if it were part of a larger figure. He writes a final note for the Atlas keepers. Cartography of the unreachable is not an act of defiance. It is a discipline that uses correlation, symmetry, and flow to extend the range of inference without pretending to add new photons. It knits lensing, clustering, velocities, and intensity maps into a fabric whose boundaries are honest and whose interior is rich enough to feel the pull of its own missing edges. The result is not a shortcut around horizons. It is a more complete reading of the clues they allow. In that reading, the maps become more than pictures. They become arguments that the world extends beyond the canvas in ways the canvas itself requires. He holds a clock beside a compass and learns that directions in time can be stranger than directions in space. The pressure that drives the expansion to quicken is not a gust of wind, but a property that looks like weight with a sign that pulls outward. He calls it dark energy, though the name explains nothing. Its effect is measurable. Distances grow faster and faster, and the fabric of the universe acquires a calm but relentless acceleration. What this means for fate is not a matter of drama alone. It is a geometry with outcomes. If the driving pressure is exactly constant, the far future resembles a quiet, nearly empty stage. Galaxies not bound by gravity to our own island will drift out of reach. The night will thin to a few persistent companions held by local ties. The background radiation will stretch into wavelengths so long that no instrument, however patient, could gather more than a lonely trickle. In such a world, time does not end. Meaningful contact does. A horizon forms that marks the last chance for one place to know another, and that horizon carries a temperature so low it feels like silence. The cosmos tends toward a desitter like repose, a state not of cessation but of dwindling conversation. This repose is punctuated by slow fireworks. Stars exhaust their fuel and leave embers. Gas grows scarce and star formation fades. Planets chill and exile their atmospheres. Collisions still occur as orbits precess and as dark matter and baryons settle, yet the drama is local and decays with each passing eon. Black holes gather the wreckage into deep wells where time dilates and light struggles. Evaporation by quantum effect steals their mass photon by photon across spans that are sums of many cosmic ages. A giant black hole can glow away for lengths of time that mock any earthly calendar, then end with a final sigh of soft particles. After that, the stage is a thin soup of the coldest quanta. There are variations on this script. If the driving pressure is not constant but creeps in time, the fabric may be more capricious. A pressure that grows in magnitude could tear structures apart in a far epoch, beginning with clusters, then galaxies, then solar systems, and finally the bonds that hold atoms. This path is called a big rip, though the name understates the patience involved. The tearing would not be a snap, but a schedule with appointments kept over unthinkable spans. Conversely, a pressure that fades could return the expansion to a gentler pace. The event horizon might then recede, and in the deepest future, some conversations postponed might become possible in principle, though the energy to speak would be hard to find. He considers alternative endings that demand very different early rules. A universe might reverse and collapse if the energy budget were weighted toward matter and curvature instead of a persistent outward push. A big crunch would then mirror a big bang in reverse order, heat rising as distances fall. Most measurements argue against this path for the world he sees, yet the scenario remains a theoretical counterpoint that clarifies how sensitive fate is to the sign and size of pressure. Another path imagines cycles, a dance of expansion and contraction, stitched to transitions in fields that reset conditions. The cycles would carry memory in their pattern of ripples and composition. Whether they can survive entropy's insistence and avoid fragile fine-tuning is an open test. Thermodynamics offers its own stern portrait. Entropy grows. Structures that lower entropy locally pay the price by exporting disorder into their surroundings. Over very long durations, the gradients that power complexity flatten. Heat death is an old phrase for a state where free energy is scarce and work becomes rare. In the accelerated case, horizons complicate the account, since the maximum information that can be stored in a causal domain is finite and tied to the area of its boundary. The future then is not only cold, it is bounded in the number of distinct states accessible to any persistent observer inside a patch. He realizes that the late universe is not a blank infinity. It is a finite theatre with diminishing props. He asks about the deep stability of matter in such a theatre. Protons may decay if grand unification, or something like it, is true in the foundation. The expected lifetimes are so long that no experiment has yet seen a solitary proton surrender. If decay exists, then even the most stubborn remnants of normal matter will not endure forever. They will seed the bath with lighter particles and radiation, adding to the entropy while removing another storehouse of order. If proton decay does not occur, isolation still wins. Dense remnants, cooled to near absolute zero, drift in a dark ledger where interactions become vanishingly infrequent. In both cases, time erodes complexity by exhaustion rather than by catastrophe. He thinks about recurrence, the faint idea that a finite system might eventually revisit patterns through random fluctuation if given inconceivable duration. Horizons and gravity muddle the classical picture of recurrence. Any exact claim would require a theory that unites quantum rules and space-time at all scales. He keeps the possibility as a caution rather than a promise. It warns that late-time stories can hide paradoxes if one extrapolates blindly. It does not offer a practical rescue from meaning in ages where resources have thinned to a whisper. Elsewhere becomes a word with temporal shades. In one sense, elsewhere is the region outside the event horizon, a spatial location no signal can reach. In another sense, elsewhere is the set of epochs so far ahead that no device can carry a record intact into them. A civilization can move through space to seek novelty. It cannot escape the arithmetic of expansion and decay. A future long enough will make even the richest archive illegible. He feels no bitterness in this. Limits clarify craft. They tell the living when to look hardest, and which messages to send while sending is possible. He wonders about strategy under such limits. An intelligent species might gather into gravitationally bound enclaves near long-lived stars, tapping slow fusion for trillions of years. It might build archives encoded in robust materials, embed memories in stable orbits, distribute redundancy across many systems to survive local misfortunes. As the horizon tightens and resources thin, the focus might shift from expansion to conservation, from voyage to stewardship. The narrative of progress would become one of fidelity rather than conquest. the maintenance of meaning in a cooling world. Whether such plans can outlast the drawdown of free energy is a question not of optimism but of physics. He looks again at the equation that drives acceleration and sees in it a philosophical contour. A positive vacuum energy is pressure that pushes all places apart while acting identically in all places. It is democratic and indifferent. It does not choose favorites. It sets a universal tendency that only local binding can counter. Fate, then, is a tug of war between a featureless background and the knots tied by gravity. The knots are temporary. The background is patient. That patience is the decisive actor in the long term. He allows himself to picture the last scenes if nothing interrupts. On scales larger than local clusters, there is no audience. Light from distant provinces no longer crosses the gulf. On smaller scales, a few galaxies remain in quiet orbits. Their stars turn to embers and ash. Black holes glow and fade. The sea of radiation spreads thin. Temperature falls toward the de Sitter floor set by the horizon. The difference between object and environment loses sharpness. Eventually, only sparse excitations flicker in the quiet. Time continues, but change surrenders. The meaning of such an end is not desolation. It is measure. A beginning loaded with free energy unfolds into forms that understand beginnings. Those forms are transient by the same rules that allowed them to arise. The storyline is not betrayal. It is symmetry between origin and outcome written in the idiom of expansion and decay. He notes that the moments of greatest clarity lie in the middle act, when information is abundant and channels are open. That is the value of the present. It is a narrow window where observation and inference can reach across much of space and time. The window closes slowly, and it never slams, but its narrowing is sure. He keeps one last question near the surface. Could the agent of acceleration be a field that interacts with matter in subtle ways, a field that can be mapped or perturbed? If so, careful measurements of growth and geometry may reveal a departure from simple constancy. Tracking the equation of state across redshift becomes a way to see if fate is set or if it can still bend. A bend would not be a promise of reunion with distant realms, but it would redraw the line between possible and impossible. The future is thus not entirely sealed. It is provisional, conditioned on a parameter that observation continues to constrain. He closes his notebook with an unhurried recognition. Time's far shore is neither cliff nor paradise. It is an asymptote in a diagram, a slowing of voices, a sunset that stretches for ages. The pull of dark energy does not fight against meaning. It defines the scale on which meaning must be found. To understand that pull is to see the horizon for what it is, a boundary drawn by a temperament of the universe itself. To live within it is to respect the window that exists now, and to treat knowledge as a form of care taken before the lights grow thin. He stands at a rail of quiet thought and finds that the truest horizon is not a circle in space, but a contour inside attention. Instruments can be polished, equations can be refined, and archives can be enlarged. Yet every question eventually asks something of the one who asks. Curiosity is not a lens pointed outward alone. It is a discipline of listening that shapes the listener. The limit on what can be seen becomes a teacher of how to see. In that education, the human project acquires scale, patience, and care. He learns to cherish residuals, those small mismatches between expectation and sky that refuse tidy dismissal. Residuals are where humility practices its grammar. They are invitations to check biases, to audit pipelines, to build a second instrument that reaches the same answer by a different road. He discovers that error bars are not fences around possibility. They are bridges across disagreements, agreements in waiting that allow many hands to work without calling victory too soon. In the presence of horizons, modesty is not caution alone, it is method. He sees that language is a tool no less than a detector. A metaphor can clarify, and it can also smuggle confusion. He chooses images that keep geometry intact, that honor the finite speed of signals and the difference between motion through space and the growth of space itself. He avoids the temptation to declare a beyond as if it were a neighbouring province on a tourist map. He speaks of relationships, of causal diamonds, of screens that tally the count of states. In this restrained vocabulary he finds nobility rather than austerity. Words that refuse exaggeration make room for wonder to stand unforced. He learns to make peace with incomplete stories. A blank in the ledger does not compel invention. It compels better inference. When a measurement cannot reach, he asks what can be triangulated indirectly, what symmetry can be exploited, what correlation can be cross-checked. He collects standard candles, rulers, sirens, and clocks, not as talismans, but as complementary senses that reduce ambiguity. He accepts that some uncertainties are durable companions. Their presence is not a failure of intellect. It is a signature of living inside one sky. He watches communities form around questions and realizes that the culture of inquiry is part of the instrument. Teams that rotate leadership, that publish null results, that share calibrations, and that welcome competing analyses build reliability the way a lattice builds stiffness. He notices that generosity in credit and redundancy in method are not niceties. They are structural supports for truth, in a world where horizons deny any single observer the power to check everything alone. The ethic of collaboration becomes a response to the geometry of limitation. He keeps a ledger of meaning that refuses to be provincial. The same curiosity that weighs a galaxy must be able to weigh a decision. If acceleration is a fact and isolation a forecast, then the time when evidence is abundant is precious. He argues, quietly, for stewardship of archives, for open data that future minds can revisit with new tools, for observatories that outlive their inventors, and for education that teaches not only facts but the posture of receptive skepticism. In such stewardship, the horizon is not a defeat. It is a schedule that asks for timely care. He senses that art is a necessary ally. Numbers chart a world, but the heart learns proportion from images, music, and story. He listens to compositions that stretch with sparse tones the way expansion stretches light. He studies photographs of deep fields where faint smudges stand like syllables of a distant language. He reads lines in which poets transform darkness into distance rather than into emptiness. He sees that when metaphor is careful, it can lift attention without distorting the science. He places art beside measurement, not as decoration but as a calibration for feeling, so that wonder does not wander into fantasy. He contemplates purpose without haste. The drive to cross horizons dies in physics and lives in ethics. No ship can outrun the speed of light, yet a civilization can outgrow greed, violence, and neglect. He imagines communities that treat knowledge as a commons, that partition resources with a view towards centuries, that design cities and networks with a tolerance for failure and a will for repair. The universe does not promise longevity to meaning, yet meaning can extend its lease through prudence and empathy. The recognition of limits becomes a foundation for responsibility. He allows himself to think about messages to distant heirs who may never read them. The act of writing for a reader that cannot reply is practice for living in a universe with an event horizon. He records methods with an honesty that future auditors can trust. He captures raw data with the metadata needed to interpret it long after the software that gathered it has become unreadable. He places code and context in redundant vaults, resisting the drift toward obsolescence that erases so many careful works. He understands that the most durable gift is not a conclusion but a recipe for how conclusions were reached. He turns his attention inward one more time and asks what wonder is for. Wonder is not a narcotic, nor is it a replacement for rigor. It is an energy source that powers careful work through years of calibration and nights of dull waiting. It prevents cynicism from masquerading as sophistication. It keeps minds soft enough to learn and strong enough to resist wishful shortcuts. In a cosmos where large regions will remain forever dark to contact, wonder converts the accessible into a festival of questions that can still be answered. He keeps vigilance against fatalism. The existence of horizons does not justify passivity. Within the diamond of causal reciprocity, choices matter. A species can stabilize climate, preserve biodiversity, and allocate attention to both urgent needs and long horizons. It can build instruments that test subtle predictions and instruments that serve survival. Choices accumulate into conditions that either free or constrict future curiosity. He sees that care for planet and craft is a single posture when measured on cosmological timescales. He ends the inventory with gratitude. The observable universe is already enormous, already rich enough to occupy thousands of generations with honest work. The facts available now are a privilege that future ages may not share when evidence grows thin. To live at a time when the afterglow of the beginning remains legible, when galaxies still crowd the sky, and when signals from mergers sing across interferometers is to be offered a banquet. Gratitude turns consumption into conservation, experiment into ceremony, and calculation into praise. He lets one last image settle. A shoreline at dusk holds a line of light that is not the boundary of the sea, but the reach of vision. Birds cross it without noticing, ships fade through it, and currents ignore it. Yet the line instructs the watcher to look, to take the measure of waves and stars, and to love the bareness of what cannot be crossed. The line returns each evening, always in the same place from the point of view of the one who looks, always in a different place from the point of view of the world. In that oscillation he finds a truth large enough to carry. The edge is not an obstacle to meaning. It is the shape of meaning when attention is honest, tools are humble, and care is wide. He closes the notebook of star numbers and opens the notebook of human numbers, the budgets of time and trust that every community must keep. He writes that limits are the frame within which craft becomes art, that horizons are the reasons methods grow kind, and that the unknown is not a threat but a covenant. The covenant reads simply: attend carefully, share generously, speak precisely, leave instructions, and remember that to ask what lies beyond the edge is to tend what lies within reach, for as long as light allows. Word count 1,180. 1. He quiets the room and lets a last passage move forward, untethered to instruments, content to be a hymn for attention. The night is a patient mirror. It does not praise, and it does not reproach. It receives the small flare of a city, the thin lines of aircraft, the soft pulse of a beacon on a mountain, and it keeps the record. In that book of dark paper, every mark is a vote for meaning. He asks the question one more time and hears no answer, only the sound of his own breathing and the click of a clock that belongs to no one. The silence is not empty. It is distance, and distance is a kind of mercy that keeps scale honest. He imagines a child who lifts a hand to cover a bright star, and learns that the hand is close and the star is not. Perspective is a first telescope. Later, another hand will hold glass to gather more light, and another will sort numbers into patterns, and another will write code that waits all night without complaint. Between the hands flows a river whose water is attention. The river carries questions wider than the boat that rides it. The banks are patience and restraint. The stones under the surface are facts that glint when the sun strikes them right. He thinks of names whispered to the sky, names of people who tightened bolts in cold wind, who soldered boards under fluorescent hum, who trimmed noise with quiet grace, who wrote terse comments in files they did not expect anyone to read. The sky keeps those names the way a coastline keeps footprints that the tide erases and reveals. The tide is time. The footprints are everything a small species did to make its corner of the universe briefly luminous with understanding. He watches the horizon line soften. It is not a wall. It is a promise that there will always be more than any eye can hold. He accepts the promise and the limit together, and he blesses them both with the only blessing a watcher can give. He will attend, he will teach, he will keep records in careful ink. He will let wonder be the voltage in the circuits of method. And when the night has thinned the background to a hush, he will remember that the hush itself is a message from a beginning that trusted light with the task of telling the story.